the sun will have a fate such as this, where at the end its outer layers of gas will escape into space?
In an unfathomably large universe where stars are created and perish in the span of a cosmic eye, humanity is about to witness a remarkable revelation. In the midst of a sea of stars, Earth, our one and only home, might soon have a counterpart in the shadows of space. Our nearest star neighbor's habitable zone is home to the exoplanet Proxima B, which beckons with unsolved secrets. Could the secret to our survival in the future lie in this far-off world? Is it a mirage amid the vastness of space, or is it a refuge yearning to embrace life? Accompany us as we explore Proxima B's mysteries under the piercing eye of the James Webb Space Telescope. What mysteries are ahead for us on this foreign planet? Is Proxima B the next chapter in the history of humanity? Most significantly, what does it signify for our species' future as we reach out to maybe touch another Earth across the gap of darkness? Earth is a lone oasis in our solar system's cosmic desert. Its singularity, being the only planet known to harbor life, cannot be emphasized. Earth, a paradise created by the most fortunate events in the cosmos, has a delicate mix of water, atmosphere, and a magnetic field that protects us from the sun's harshest winds. This utopia, our home, is tucked away in what scientists refer to as the Goldilocks zone, a temperature that is just right for life as we know it to flourish, neither too hot nor freezing. However, staring up at the night sky serves as a reminder of both the immensity of space and the possibility of other worlds being similar to our own. Let's introduce Proxima B, an exoplanet around Proxima Centauri, our nearest galactic neighbor, a red dwarf star. Both scientists and dreamers have been fascinated by this universe. Why? Because Proxima B, like Earth and the Sun, is situated exactly within the habitable zone of its star. This placement raises the exciting prospect that it might have conditions conducive to life. Proxima B, however, is a universe of contradictions and secrets. It is a planet that defies our idea of habitability, orbiting a star that is much colder and dimmer than our Sun. Could it have enough atmosphere to hold on to heat and hold liquid water? By penetrating the haze around Proxima B, the James Webb Space Telescope has allowed us to get glimpses of what may be humanity's next frontier. In addition to intriguing us with the possibility of water and habitable conditions, this Earth-sized exoplanet poses important issues regarding the nature of life in the cosmos. Traveling to Proxima B, a possible new Earth surrounded by the gravitational pull of space and Earth's environmental boundaries, could be humanity's most exciting expedition to yet, with the potential to redefine our role in the universe and solve deep questions. Challenges within our solar system. The idea comes up, why not settle elsewhere within our own solar system as we stare out into space and consider our place among the stars? It's our cosmic backyard after all. The harsh truths of space, however, face us as we examine the strata of each celestial body orbiting our Sun, and this is why Earth continues to be our only haven in the solar system. The inner planets are our neighbors, but their surroundings are not friendly at all. Mercury experiences temperatures that are hot enough to melt, lead due to its close proximity to the Sun. With no atmosphere, its surface provides no defense against the Sun's deadly kiss. Venus's dense, poisonous atmosphere puts visitors under pressure comparable to being submerged a kilometer below the surface of the Earth, not to mention the unbearable heat that even eclipses that of Mercury. Despite having sparked our curiosity and aspirations, Mars is a desolate wasteland with a thin atmosphere that provides little protection from cosmic radiation. The harsh environment and absence of a magnetic field make long-term human survival extremely difficult. There is no stable surface to stand on among the gas giants, Jupiter, Saturn, Uranus, and Neptune beyond Mars. Though fascinating, their moons present unique survival difficulties. NASA has investigated these heavenly bodies in an effort to find possible safe havens. Callisto and Titan stand out among the moons as potential locations for permanent habitation. Jupiter's moon. Callisto stays out of the deadly radiation bands that encircle its planet. Its impact-scarred surface suggests a stable environment, making it one of the safer locations for explorers to come. Titan, the biggest moon of Saturn, has lakes of ethane and methane as well as a dense atmosphere. Its air pressure is comparable to Earth's, and the complex organic chemicals it contains arouse curiosity. Could human settlements or even outposts be supported by these moons? Even yet, these moons pose significant challenges. It is incredibly difficult to imagine human settlement there due to the intense cold, scarcity of breathable air, and distance from the sun. A base would need a tremendous amount of energy just to be operational, not to mention the psychological effects of living in such a harsh and isolated place. The difficulties of space travel within our solar system serve as a reminder of how special Earth is and emphasize the need to investigate possible new planets like Proxima B. Meanwhile, the moons Titan and Callisto provide priceless lessons in space survival and may prove to be crucial stops on humanity's cosmic journey. Proxima B's discovery and potential astronomers and space enthusiasts have shown interest in Proxima B, a planet that is tucked away in the cosmic neighborhood and only 4.25 light-years from Earth. This exoplanet, which is orbiting Proxima Centauri, the star nearest to our solar system, possesses features that pique curiosity and inspire bold investigation. What, though, is so unique about Proxima B? And why are researchers focusing their hopes and telescopes on it from all across the world? To begin with, Proxima B is pleasantly situated within Proxima Centauri's habitable zone. The temperature in this Goldilocks zone is ideal for the possible existence of liquid water on the planet's surface, since it is neither too hot nor too cold. Since water is essential to life as we know it, its existence on Proxima B may indicate that life as we know it is possible on the planet. However, the fun doesn't end there. The most sophisticated space observatory ever built by humans, the James Webb Space Telescope, JWST, has turned its attention to this fascinating planet. JWST's unmatched sensitivity to infrared light allows it to identify the chemical signatures of different gases and water in Proxima B's atmosphere. These discoveries may give light on the planet's surface characteristics, potential for supporting life, and climate. Proxima B's possible habitability, meanwhile, is not without its mysteries and difficulties. The planet may be tidally locked based on its close orbit around its star. This indicates that one side of the planet is always exposed to daylight since it is continually facing its star, while the other side is always covered in darkness. This has wide-ranging and intricate effects on life. On the one hand, the planet's perpetual daylight may enable photosynthesis in some areas, but the sharp temperature variations may also lead to extreme weather patterns. In spite of these doubts, Proxima B is now in the forefront of candidates for habitable planets outside of our solar system because to JWST discoveries. In addition to providing an answer to the age-old query of whether or not we are alone in the universe, the information acquired by this space telescope may also provide clues about future human exploration and potential world colonization. The James Webb Space Telescope is positioned to offer solutions to the puzzles surrounding Proxima B, which are casting doubt on the possibility of a second Earth and altering our understanding of life outside of Earth. The hurdles of habitability. Proxima B offers a mosaic of opportunity and danger. In our search for a second Earth, this alien world around the star Proxima Centauri offers promise. It is not without difficulties, though. Its dense atmosphere and tidally locked location present two significant obstacles that stand out and complicate the concept of habitability. Let's examine the atmospheric puzzle first. If the atmosphere of Proxima B is more like that of Venus than Earth, it may act as a barrier as well as a constraint. Future settlers might be shielded from cosmic radiation by a dense atmosphere, which is a serious risk for any space traveler. Nevertheless, there is a catch to this barrier of defense. A runaway greenhouse effect could result from it trapping heat to a lethal degree if it is overly dense. Rather than providing refuge, the surface can turn into a blazing fire that dashes any dreams of settlement. This harmony between safety and danger emphasizes how important atmosphere is in deciding how habitable a planet is. Additionally, Proxima B's tidally lock is an issue. Imagine that one side is always bathed in light and the other is covered in darkness. Unlike Earth, such a globe does not revolve around its axis. As a result, one hemisphere will always face its star, while the other will always face the light. The effects on the climate are significant. The day side can be completely burned, a desert where the temperature soars to uninhabitable heights. It's possible that the night side is a pitch-black, frozen wilderness in the interim. There is, however, some optimism in the gray area between these two extremes. Could this thin strip provide a haven of temperate safety, where water stays liquid and life as we know it takes root? This is where science shines its light, though. It is not only necessary to recognize barriers to comprehend Proxima B's atmosphere and its tidally locked state, but also to discover opportunities. Could Proxima B become more Earth-like through terraforming or advanced technology? Could we learn anything from Earth's own climatic changes to assist us deal with the difficulties of a new world? Proxima B's peculiar orbit and thick atmosphere challenge our ideas of habitability and encourage us to imagine humanity's potential flourishing beyond Earth, despite the severe challenges. Exploring Proxima B is an exciting but scary trip. The intricacies of space, exploration, the James Webb Space Telescope, JWST, a marvel of human ingenuity and our most sophisticated window into the cosmos, is at the vanguard of this cosmic detective work. JWST's goal extends beyond merely photographing far-off stars or galaxies. It also involves discovering the details of possibly habitable exoplanets, such as Proxima B. These far-off planets, light years from Earth, provide a significant challenge. How can we, from our vantage point, determine whether they have the elements required for life as we know it? The JWST's capacity to identify and examine the little light glimmers that leave these far-off planets holds the key to the solution. The James Webb Space Telescope, JWST, is able to identify indicators of water, oxygen, methane, and other essential elements that point to the existence of an atmosphere conducive to life by analyzing the spectrum of light that travels through a planet's atmosphere. This is no easy task. Because of their faintness and remoteness from the enormous background of cosmic radiation, these signals must be isolated and identified using highly sensitive detectors and advanced algorithms. However, the JWST travels farther still. With the help of its powerful infrared vision, it can see into these planets' thermal emissions to learn more about their surface temperatures and weather patterns. This is essential to knowing if a tidally locked planet with a constant day side facing its star, such as Proxima B, can sustain a temperature that keeps water from freezing into permanent ice on its dark side or evaporating completely on its sun-facing hemisphere. Furthermore, another component of the habitability problem is the possibility of geological activity indicated by the telescope's observations. For example, volcanic activity, like that of Earth, can replenish a planet's atmosphere and disperse necessary chemicals throughout its surface. The JWST essentially combines the functions of a chemical sensor and a time machine, enabling us to study planets' atmospheres that are billions of miles away. It searches the reaches of space for the faint murmurs of worlds that could, beyond all odds, support life. Despite the obstacles, the complexity of space exploration, led by the JWST, opens a new chapter in our search for a second Earth and offers hope for the resolution of humanity's deepest queries regarding extraterrestrial life and our cosmic neighborhood. Cutting-edge technologies like the JWST also shed light on the mysteries of the cosmos and our place within it. The future of human space exploration. Our imagination is just the beginning as we prepare for what may be the most revolutionary voyage in human history, the mission to Proxima B. The immense expanses of space present challenges not only to our technological capabilities, but also to our ability to collaborate and envision internationally. Today, we're going to examine two of the most exciting technologies that have the potential to make science fiction a reality: nuclear pulse propulsion and photonic propulsion. The idea of photonic propulsion, which sounds as futuristic as it gets, uses light's inherent power. Imagine a spaceship, no larger than a chip, that is driven by laser light beams from Earth to travel at a speed of 1/5 the speed of light. Russian billionaire Yuri Milner, together with notables like Mark Zuckerberg, has invested $100 million in the breakthrough Starshot project to make this a reality, so it's not just a pipe dream. Photonic propulsion is aesthetically pleasing due to its ease of use and effectiveness. In less than 20 years, these nanocrafts might arrive at Proxima B without having to transport bulky fuel. However, the obstacles are enormous. At such high speeds, shielding these small explorers from cosmic dust and gas needs creative solutions, such as ablative coatings that shed material and shield the craft's critical sensors. Nuclear pulse propulsion, which evokes memories of the Cold War yet has a peaceful, exploratory purpose, is at the opposite end of the spectrum. The concept is as audacious as it is straightforward. To advance a spaceship, set off a sequence of nuclear explosions behind it. Space is the ideal vacuum for such dramatic propulsion techniques, free from worries about nuclear fallout or environmental harm, despite the fact that this may sound frightening. This is not simply a theoretical idea. Research initiatives from the 1950s have established the foundation, and with current developments, it may offer the impetus required to close the interstellar gap. However, reaching Proxima B is more than just a matter of propulsion. It's an example of human cooperation and inventiveness. It will take unprecedented global cooperation to reach speeds and technologies that were previously only found in science fiction. The voyage to Proxima B might unite our globe in pursuit of a common goal, landing on a new world. This could involve anything from building gigantic laser arrays for photonic propulsion to reaching a consensus on the safe use of nuclear pulse propulsion. The search for Proxima B represents humanity's cooperative step towards expanding into space, overcoming challenges with a shared sense of inventiveness and will. The vision for Proxima B. The James Webb Space Telescope's discovery of Proxima B opens a new chapter in our never-ending search for survival and knowledge as we gaze out into space. This exoplanet, which is in orbit around the star Proxima Centauri, is a source of inspiration and evidence of the insatiable curiosity that drives humankind beyond Earth. Proxima B is more than just a dot in the vastness of space. It's the possibility of a fresh start. This planet, which is located in its star's habitable zone, may have all the prerequisites for life as we know it. Because Proxima B has an atmosphere and water, which is essential for life, it may be more than just a rock floating in space. Rather, it may be a home. Proxima B is significant in ways that go beyond finding a new home. It forces us to stretch the limits of our knowledge and technology. The idea of discovering this planet highlights the incredible developments in spaceflight and propulsion technology. Our trip to Proxima B may reshape our understanding of what it means to be an interstellar species, thanks to developments in photonic propulsion that might deliver tiny probes to the stars at a fraction of the speed of light and nuclear pulse propulsion. However, Proxima B's plan is not without its challenges. The logistics and technical difficulties of traveling to a planet light years away are enormous. But these difficulties also call for creativity and international collaboration. By advancing our understanding of Proxima B, we may be able to develop technology that will benefit all of mankind both on Earth and beyond, and usher in a new era of scientific growth. Furthermore, Proxima B offers a rare chance to learn about planetary history and development because of its youth, just 15 to 20 million years old, compared to Earth's 4.5 billion years. This could provide light on the history of our planet and the life it supports, providing evidence for the resiliency of life elsewhere in the universe. Proxima B represents, in essence, the next frontier of scientific research and human exploration. Its finding serves as a stark reminder to carry out space, exploration and research, pushing us to gaze beyond the boundaries of our world and toward the stars. Beyond only traveling across space, the search for knowledge about Proxima B is a voyage into the future of humanity. We are reminded that the universe is meant to be experienced, comprehended, and maybe even called home one day as we stand on the precipice of our cosmic journey. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
We're never going to stop exploring the unknown in air and space.
Voyager 1 will soon pass Neptune, exiting the solar system to become an interstellar wanderer. For over 46 years, this pioneering spacecraft has unveiled secrets from the far reaches of our solar system. Recently, it has been sending mysterious messages from 24 billion kilometers away, leaving NASA's team baffled. What groundbreaking discovery has Voyager 1 made at such a distance, and what could it mean for life on Earth? Join us as we unravel the enigma of Voyager 1's unexpected communication with a nearby object in space. Exploring Voyager 1's present circumstances demands a deep dive into its remarkable voyage. The Voyager mission commenced in September 1977 with an original projection of about 5 years. However, both Voyager 1 and Voyager 2 have far exceeded this anticipated duration. They continue their extraordinary odyssey through space, vastly surpassing their initial mission timeline. For over 46 years, these spacecraft have been traversing space, transmitting crucial data from distant celestial realms. Initially dispatched to investigate Jupiter and Saturn, the Voyager spacecraft performed exceptionally well in their assigned tasks. Voyager 2, however, embarked on an extended journey, venturing close to Uranus in 1986 and Neptune in 1989, a mission known as the Voyager Grand Tour. The apex of their expedition occurred in 2012, when Voyager 1 achieved a groundbreaking milestone by transitioning beyond our solar system into what scientists term interstellar space. The confirmation of this monumental feat did not occur immediately, but was validated in 2013 upon meticulous analysis of Voyager 1's data transmissions. NASA officially acknowledged Voyager 1 had indeed entered interstellar space. Throughout its voyage, Voyager 1 encountered novel particles and magnetic phenomena, unveiling previously unknown scientific insights. Subsequently, in 2018, Voyager 2 also ventured into this expansive cosmic realm significantly distant from the Sun. Presently, Voyager 1 stands as humanity's farthest creation, residing approximately 24 billion kilometers away from Earth, marking an extraordinary distance in space exploration. NASA's Jet Propulsion Laboratory shares fascinating insights about Voyager 1's remarkable journey into the vastness of space. Imagine Voyager 1 as a high-speed traveler hurtling away from us at an astonishing pace of 38,000 km, which translates to approximately 17 TS. This spacecraft, part of the iconic Voyager missions, stands apart for its invaluable contributions to our understanding of the solar system and its surroundings. Voyager 1 has been diligently at work, delving into the interactions between extraterrestrial matter and the solar emissions from our Sun. Through its extensive data collection, Voyager has shed light on the intricacies of the heliosphere, a protective bubble encompassing our solar system comprised of charged particles. NASA's experts have amalgamated Voyager's discoveries with insights from newer space missions, enhancing our comprehension of solar dynamics and the interface between our heliosphere and interstellar space. Remarkably, Voyager 1 has persisted in its mission for an uninterrupted 46-year journey, continually expanding our knowledge and fueling our curiosity about the cosmos. Consider the possibility raised by some scientists that alien civilizations, if they exist, might have intercepted Voyager's transmissions as early as 2002. The prospect of a rendezvous with extraterrestrial beings captivates the imagination, raising profound questions about potential encounters beyond our planet. However, before contemplating such encounters, let's marvel at Voyager 1's endurance in the harsh environment of space. Space presents formidable challenges, including intense radiation, extreme temperatures capable of instant freezing or burning, and the constant hazard of micrometeoroids. Yet against all odds, Voyager 1 has persevered for more than 46 years since its launch on September 12, 1977. The enduring success of Voyager 1 can be attributed to its exceptional design and engineering. The spacecraft owes its longevity to the remarkable skills of the engineers who meticulously crafted it. These individuals deserve immense credit for ensuring that Voyager 1 could withstand the harsh conditions of space, including exposure to cosmic radiation, extreme temperature fluctuations, and potential collisions with space debris. One crucial aspect of Voyager 1's design is its power source. Unlike spacecraft that rely on solar panels for energy, Voyager 1 utilizes a more sophisticated system known as radioisotope thermoelectric generators. These nuclear batteries operate by harnessing the heat produced from the natural decay of plutonium and converting it into electricity. This innovative technology has served as Voyager 1's reliable source of energy for over 4 decades, akin to a steady heartbeat that keeps the spacecraft functioning optimally. Despite the gradual decrease in power due to radioactive decay, the RTGs continue to provide sufficient energy to power the array of advanced scientific instruments on board Voyager 1. These instruments function as a comprehensive toolkit, equipping the spacecraft with capabilities akin to those of a skilled explorer armed with a versatile Swiss Army knife. Among the impressive instruments on board Voyager 1 are the Cosmic Ray Subsystem, High-Gain Antenna, Imaging Science Subsystem, Infrared Interferometer Spectrometer, Radiometer, Low-Energy Charged Particles Detector, Magnetometer, Optical Calibration Target, Photopolarimeter, Subsystem, Planetary Radio Astronomy Instrument, Plasma Science Instrument, Plasma Wave Subsystem, and Ultraviolet Spectrometer. Each of these instruments plays a vital role in conducting scientific observations and experiments, contributing valuable data to our understanding of the cosmos. The instruments aboard Voyager 1 are not just fancy names, they are tools essential for conducting thorough investigations. These instruments have enabled Voyager 1 to reveal secrets about large planets and their moons. It captured detailed images showing Jupiter's dynamic cloud patterns, turbulent storms, and volcanic activity on one of its moons, Io. Similarly, at Saturn, the rings were not just visually appealing. They displayed intricate structures like twists, turns, spokes, and numerous smaller ring segments. However, the significance goes beyond mere visual documentation. These instruments have functioned as cosmic investigators, examining cosmic rays, analyzing charged particles, studying magnetic fields, and recording plasma waves. Voyager 1 is equipped with these tools to aid our understanding of space's mysteries. As Voyager 1 traverses through space, it carries a notable artifact, a message from us, Earth's inhabitants, intended for any potential encounters during its endless voyage. This extraordinary message is known as the Golden Record, a 12-inch disc crafted from gold-plated copper, containing various sounds and images carefully selected to depict Earth's life and culture. It offers a glimpse into our world, narrating our story and showcasing our planet with the aim of establishing a connection with potential extraterrestrial entities. Encoded within this illustrious disk are 116 images and a diverse array of sounds, including musical compositions, greetings spoken in 55 languages, and the raw sounds of nature such as thunder, bird calls, and whale vocalizations. This whole collection was carefully curated by a team led by the renowned astrophysicist Carl Sagan. Their goal was to create a vibrant fabric showcasing the diverse cultures and experiences of our planet. Voyager 1, along with its companion Voyager 2, safeguards this precious golden record, holding within it a message that could potentially be discovered by extraterrestrial beings in the distant future. The mere thought of these small spacecraft carrying our message into the vast unknown is truly inspiring. Consider this hypothetical situation. An advanced extraterrestrial civilization encounters Voyager 1 and retrieves the golden record. Such an event would mark a monumental milestone in the annals of interstellar communication. Here are 3 plausible outcomes that might unfold. Firstly, these extraterrestrial intelligences would likely utilize their advanced technology to decipher the contents of the golden record, unraveling its visual and auditory messages like solving a futuristic puzzle. Secondly, if these beings possess the capability to traverse the stars or communicate across vast cosmic distances, there's a possibility they might respond to our message, potentially initiating a mind-boggling exchange of information. Imagine receiving a signal from outer space as soon as 2029, a truly remarkable prospect. However, there's a third scenario to consider. These extraterrestrial entities might opt not to interfere with Voyager 1, treating it as a historical artifact to be studied from a distance without direct intervention. Some scientists speculate that they might adhere to a non-interference principle, respecting the natural progression of other civilizations, akin to the concept depicted in various science fiction narratives. Regardless of the outcome, encountering extraterrestrial beings would undoubtedly be a momentous and possibly transformative event for humanity. Voyager 1 has recently piqued the interest of space enthusiasts and NASA engineers alike due to some intriguing developments in its mission. The source of this excitement is a perplexing discrepancy in the data relayed by its Attitude Articulation and Control System, AACCS, a critical component responsible for maintaining the spacecraft's orientation and ensuring its communication antenna remains directed towards Earth. This anomaly has left NASA's engineers scratching their heads as the data from the AACS doesn't align with Voyager 1's actual trajectory. It's akin to a seasoned traveler momentarily losing their sense of direction amidst the vast expanse of space. However, amidst this mystery, there's a silver lining. Voyager 1 continues to dutifully execute its tasks, responding promptly to commands from Earth and continuing its scientific odyssey unfazed by the discrepancies in its telemetry data. One of the most remarkable aspects of this saga is Voyager 1's unwavering signal strength, which steadfastly maintains its alignment with our home planet. Yet, the mystery deepens as the erratic nature of the AACS data occasionally defies comprehension, adding layers of intrigue to Voyager 1's ongoing narrative. Susan Dodd, the overseer of both Voyager 1 and its companion Voyager 2, sheds light on this captivating puzzle. She reminds us that encountering such mysteries is not uncommon as these intrepid spacecraft near the culmination of their extraordinary journeys. Having far exceeded their intended operational lifespans, these interstellar pioneers have ventured beyond the wildest imaginations of their creators, enduring the rigors of interstellar space and emerging as unparalleled emissaries of human ingenuity. While the engineering team grapples with the challenge posed by Voyager 1's AACS anomaly, there remains an air of optimism regarding a potential solution. Identifying the root cause of this discrepancy could pave the way for adjustments in the spacecraft software or the activation of backup hardware systems, offering a glimmer of hope amidst the complexities of deep space exploration. Interestingly, Voyager 1 has confronted and overcome similar hurdles in the past, such as the wear and tear of its main thrusters. In 2017, engineers exhibited remarkable ingenuity by resurrecting dormant thrusters, dormant since the early days of Voyager's missions, to ensure the continuation of its odyssey. NASA's brilliant engineers successfully resolved the problem with Voyager 1. It turns out that the AACS was sending data to a computer that had stopped working, causing confusion in the information flow. The project manager suspected this issue and took a bold step by redirecting the AACS to send data to the correct computer. While the exact reason for the AACS malfunction remains unclear, the team believes it might have originated from a glitch in another onboard computer, indicating a potential underlying issue elsewhere on the spacecraft. The team is committed to uncovering the root cause of the problem, although they are confident that it does not pose a significant threat to Voyager's overall functionality. Nevertheless, they are eager to gain a deeper understanding of Voyager 1's internal operations. However, it is important to note that Voyager 1's space odyssey will eventually come to an end. Time is running out for this intrepid explorer. This raises a crucial question. How much longer can NASA's Voyager continue its remarkable journey through space? This question is intriguing and multifaceted. Before delving into that, it is essential to understand how Voyager 1 maintains communication over a vast distance of 24 billion kilometers and what factors determine its communication range before losing contact. Voyager 1's ability to stay connected relies on a sophisticated radio communication system designed to operate effectively within and beyond the boundaries of our solar system. At the heart of this system is a substantial 3.7-meter high-gain antenna. This formidable antenna plays a crucial role in transmitting and receiving radio waves through 3 Earth-based stations that constitute the Deep Space Network. When Voyager 1 talks to Earth, it usually does it through a special channel called Deep Space Network Channel 18. It uses radio waves at frequencies of either 2.3 billion cycles per second or 8.4 GHz. When we send messages back to Voyager, we use a frequency of 2.1 GHz. This setup helps Voyager 1 stay in touch with our planet while it travels through space's vastness. Because Voyager 1 has traveled so far, it's not easy to talk directly to Earth anymore. To handle this, the spacecraft has a digital recorder that can store about 67 million bytes of data. It records information that it sends back to Earth when the communication gets better. As of 2023, it takes more than 22 hours for signals from Voyager 1 to reach Earth. That's much longer than the roughly 15 minutes it takes for signals from Mars rovers. Another challenge is that Voyager 1's signal weakens a lot over such a long distance. It starts with a 20-watt signal, but by the time it reaches us, it's very weak. However, the strength of the signal isn't the main issue. What's important is having receivers that can pick up these weak signals. NASA solves this by using the Deep Space Network, which has 3 big antenna groups placed in strategic spots on Earth. Each group has a huge 70-meter antenna and several smaller 34-meter antennas. Together, these antennas can detect signals thousands of times weaker than a regular FM radio signal. The Deep Space Network spends many hours every day listening for these faint signals from Voyager 1 and is always ready to catch them. Let's explore the communication between Voyager 1 and Earth. Voyager 1 sends messages through the Deep Space Network, our bridge to the stars. When Voyager 1 transmits a signal, it's like tossing a stone across a vast ocean. The signal travels at incredible speeds but weakens over distance, becoming a faint whisper by the time it reaches Earth. The Deep Space Network's antennas, like giant listening devices, pick up these whispers amidst the cosmic noise. It's akin to hearing a pin drop in a bustling city, with the city being the universe. Over the past 50 years, our ability to detect distant space signals has greatly advanced. We can now communicate with space explorers far beyond previous limits. Today's technology enables reliable communication with objects light years away, given precise and sensitive receivers. How far can Voyager 1 travel? As it moves farther from Earth daily, it becomes a celestial messenger on an infinite journey. However, sending and receiving signals becomes more challenging with distance, slowing data rates, and complicating communication. Despite these challenges, Voyager 1's journey seems limitless in theory, but practically our communication capability will last only a few more years. Voyager 1's limited energy reserves restrict its ability to collect scientific data. The cosmic ray subsystem, vital for measuring particles from celestial objects, provides crucial insights into the universe. NASA confirms that Voyager 1 and Voyager 2 still have enough fuel for their missions. They use two types of fuel: hydrazine for maneuvering and plutonium-238 for power. Hydrazine, chosen for its cost-effectiveness and resistance to freezing, is used for attitude control. In space with no gravity to counteract, the Voyagers maintain their orientation with minimal effort, using the gravitational pull of planets as slingshots. NASA estimates they achieve about 30,000 miles per gallon of hydrazine. Voyager 1 is expected to continue its mission until around 2040, and Voyager 2 until about 2034. The key limiting factor is not their steering fuel, but plutonium-238 dioxide, which powers their equipment. These spacecraft use radioisotope thermoelectric generators to convert plutonium's decay heat into electricity. To ensure safety, the fuel is encased in a specialized alloy since their 1977 launch. Over time, the plutonium decays, reducing power output from 470 watts to around 315 watts. To manage this decline, NASA deactivates non-essential systems and intermittently operates certain instruments. An important precedent for power management occurred in 1990, when engineers made the critical decision to deactivate the cameras after capturing the iconic pale blue dot image of Earth. Today, out of the original 11 scientific instruments on board, only 5 remain operational. Engineers have had to make difficult choices, such as disabling heaters, to ensure the functionality of these active instruments. These tools play a pivotal role, providing invaluable data on magnetic fields, solar winds, and cosmic rays beyond our solar system. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
Time and space are like a fabric, like rubber, like a trampoline net. Turn this trampoline net into a pretzel and allow yourself to go backwards in time.
Imagine that time and space are like a fabric, an interconnected web that twists and bends like a trampoline net. Now twist that net into a pretzel and imagine traveling backward through time. Ever wondered what's truly out there in the cosmos? What mysteries the universe is hiding from us? Brace yourself, because we have a revelation so groundbreaking, it's about to rewrite everything we thought we knew about the universe. American physicist Michio Kaku shares a revolutionary discovery brought to light by the James Webb Space Telescope. It's a finding so extraordinary it could challenge our very understanding of space-time. Ready to dive into a cosmic riddle that will turn your perception of the universe upside down? Let's explore how this cutting-edge telescope may have proven that time, as we understand it, might not even exist. The James Webb Telescope. Launched on Christmas Day of 2021, the James Webb Space Telescope, JWST, has quickly established itself as a pioneering force in the field of astronomy. Unlike anything before it, the JWST is equipped with highly advanced infrared instruments that allow it to peer back across the vast stretches of space and time. This marvelous piece of technology has been described as the ultimate time machine, due to its capability to observe light from the early universe, which has been traveling towards us for billions of years. What sets the JWST apart is its unprecedented resolution and sensitivity, which surpass that of its famous predecessor, the Hubble Space Telescope. These capabilities enable the JWST to detect incredibly faint and old objects in the universe, ones that have remained invisible to other telescopes until now. This deep look into the cosmos provides not just a glimpse into the distant universe, but a vivid picture of the conditions and celestial phenomena as they existed billions of years ago. The true marvel of JWST's technology lies in its intricate array of instruments and mirrors. Its primary mirror, which spans 6.5 meters in diameter, significantly exceeds Hubble's 2.4 meters, capturing more light and thus providing a sharper and more detailed view of the universe. Additionally, JWST's suite of scientific instruments is specifically designed to observe in the infrared spectrum. This allows it to see through cosmic dust clouds that block visible light, revealing the hidden nurseries where stars and planetary systems are born. These capabilities not only enhance our ability to observe known cosmic phenomena, but also open up new realms of exploration. By looking at the universe in infrared, JWST can examine the atmospheric compositions of distant exoplanets, potentially identifying signs of habitability or even life. Moreover, its sensitive instruments can trace the faint signatures of the earliest galaxies, helping astronomers to unravel how the first structures in the universe formed out of the primordial darkness. By serving as our eyes into the earliest days of the universe, the James Webb Space Telescope not only expands our understanding of the cosmos, but also deepens the mysteries that surround the origins and the fundamental nature of the universe itself. This powerful observatory is not just a telescope, it's a time portal to the ancient cosmos, offering insights that were once thought to be beyond our reach. Cosmic revelation. In a recent revelation, Michio Kaku, the renowned American physicist, shared that observations from the James Webb Space Telescope, JWST, could potentially upend our current cosmological theories. The JWST, with its sophisticated infrared gaze, has captured images of galaxies that defy the traditional narratives dictated by the Big Bang theory. These galaxies are puzzling not only because of their size and age, but also due to their sheer number. Diving into the details, these distant galaxies observed by the JWST appear too small when they should look bigger due to the stretching of space itself, an effect known as cosmic expansion. Additionally, these galaxies are far older than expected. According to conventional cosmological models, we shouldn't be able to see such mature galaxies at these early stages in the universe's history. Their existence suggests that they were formed shortly after the Big Bang, much earlier than previously thought. Furthermore, the number of these galaxies adds another layer of complexity. There are simply too many of them. Traditional models based on the Big Bang theory predict a gradual formation of galaxies, starting sparsely and increasing over time. However, the JWST's findings show a universe teeming with galaxies at a time when, supposedly, they should have been few and far between. Each of these revelations challenges the cornerstone of our understanding of the universe's evolution. The small size, advanced age, and abundance of these galaxies suggest that our current models might need significant revisions, or even potentially a complete overhaul to accommodate this new cosmic perspective. This raises thrilling questions about the very fabric of our universe and invites us to rethink our place within it. Galaxy size anomaly. Imagine peering through the most advanced telescope ever built, expecting to see distant galaxies as mere specks compared to their closer counterparts. Now imagine your surprise when these galaxies look strikingly similar in size to those that are much nearer. This is the baffling reality astronomers are grappling with, thanks to the latest observations from the James Webb Space Telescope. In the standard model of cosmology, as galaxies move away from us, their light stretches, causing them to appear smaller, a phenomenon known as the redshift effect. Yet, what the JWST has shown us flips this expectation on its head. Distant galaxies, theoretically millions of light years further than those in our galactic neighborhood, are not appearing smaller at all. They're just as large, if not identical in size, to nearby galaxies. This startling observation poses a significant challenge to the idea of an expanding universe. Why does this matter? Well, if galaxies are not appearing smaller with distance, as they theoretically should in an expanding universe, we may need to reconsider our understanding of cosmic expansion altogether. Could it be that the universe isn't stretching out as once thought? This anomaly isn't just a minor glitch. It could unravel part of the fabric of cosmological theories and compel scientists to rethink some fundamental aspects of our universe's framework. As we delve deeper into these cosmic mysteries, each observation from the JWST could potentially lead us to a new understanding of the cosmos. The redshift mystery. Diving deep into the cosmos with the James Webb Space Telescope, we encounter a concept that might twist your mind. Redshift. Redshift occurs when the light from an object in space stretches out, becoming redder as it travels toward us. This phenomenon typically signals that an object like a galaxy is moving away from us, and it's been a cornerstone in supporting the theory that our universe is expanding. But here's where it gets truly bewildering. The JWST has detected galaxies with incredibly high redshifts, levels that are astonishing even to seasoned astronomers. These are not just slightly higher numbers. These are redshifts that suggest these galaxies are moving away from us at speeds previously deemed impossible under the current models of the universe's expansion. What does this mean? In theory, the higher the redshift, the faster a galaxy should be racing away from us, which in turn supports the idea of an accelerating universe. However, the JWST's observations throw a wrench into this narrative. These galaxies with unexpectedly high redshifts are not behaving as they should. They're too luminous and too massive, appearing far larger and brighter than what would be expected at such tremendous distances. This redshift mystery poses a serious challenge to the standard model of cosmology. If these galaxies are so distant, yet so developed, what does this say about the speed at which our universe has been expanding? Could our understanding of cosmic expansion be a misinterpretation of the data we're observing? These are the questions that astronomers and cosmologists are now grappling with, as the JWST continues to deliver data that might just rewrite the textbooks on the universe's grand-scale dynamics. The smooth galaxy problem. In the cosmic arena of galactic observation, the James Webb Space Telescope, JWST, has brought to light some stunning images that are causing astronomers to rethink well-entrenched theories about the universe. One of the most intriguing findings is the smooth, nearly pristine appearance of galaxies that appear to defy the chaotic aftermath expected from frequent cosmic collisions. According to prevailing theories, galaxies, especially in their formative years, should show signs of violent interactions, twisted shapes and scrambled features resulting from gravitational pulls and mergers with other galaxies. These cosmic collisions are thought to be part and parcel of a galaxy's life cycle, contributing to their growth and evolution. However, what JWST has shown us paints a different picture. The telescope's powerful infrared gaze has revealed galaxies that are not only unexpectedly smooth, but also maintain neat, orderly spiral arms, resembling the calm and composed galaxies much closer to us. This observation is startling because it suggests that these distant galaxies have not undergone the turbulent history that current models of universe formation and evolution predict. This smooth galaxy problem raises significant questions about our understanding of galactic formation and evolution. If these galaxies aren't showing the scars of numerous high-speed collisions, what does that say about the mechanisms we think drive cosmic structure? The lack of galactic fender benders suggests either our understanding of cosmic evolution is missing some pieces, or perhaps we need to revisit the fundamental principles that govern the universe's behavior. Each neatly spiraled galaxy, sitting billions of light years away, challenges the notion that chaos and disorder were dominant in the early universe. Instead, these galaxies hint at a different story of cosmic evolution, one that might be quieter and more orderly than we ever imagined. The Age of Stars issue. Diving deeper into the revelations of the James Webb Space Telescope, we encounter a particularly puzzling observation. Some of the stars within these distant galaxies appear to be older than the universe itself, according to traditional cosmological models. This startling finding suggests that these stars predate what we understand to be the Big Bang event, the supposed origin of all matter and energy in the universe. How can a star be older than the universe? The JWST's infrared gaze has detected light from these stars that suggests they are over 1 billion years old. This in a universe that, according to current estimates, is around 13.8 billion years old. These observations are from galaxies so distant that their light shows us a snapshot from just 400 to 500 million years after the universe began. Yet if we tally up the cosmic timeline, these stars shouldn't exist within it. They simply appear too mature for their cosmic age. This isn't just a minor hiccup in astronomical calculations, it's a profound enigma that challenges the bedrock of our understanding of cosmology. If these observations hold up under further scrutiny, they could force us to reconsider not just the timeline of the universe, but the fundamental physics underlying it. Could the Big Bang Theory need a revision, Or might it even be replaced by a new model that can better accommodate these ancient stars? As scientists continue to analyze the data from JWST, the age of these stars beckons as a clue in a larger cosmic puzzle. What we thought was a settled question about the universe's beginnings may just be the first chapter in a much longer cosmic story still unfolding. Now let's dive into the Big Bang Theory in particular. Implications for Big Bang Theory. The James Webb Space Telescope has brought us to a pivotal moment in cosmology, pushing us to reconsider some of the most fundamental aspects of our universe's origins. The data collected by this powerful observatory is stirring a profound debate over the validity of the Big Bang Theory. Traditionally, this theory posits that the universe began from a singular, immensely dense and hot point approximately 13.8 billion years ago and has been expanding ever since. However, the new images from JWST reveal galaxies that are too mature and too developed to have formed in the timeline that the Big Bang Theory suggests. These galaxies, with their size, smoothness, and advanced development, suggest that they were not only formed earlier than we thought possible, but also that they have not undergone the significant changes that an expanding universe would imply. This observation directly challenges the expansion model, which underpins the Big Bang Theory. If the universe has not been expanding in the way we've theorized, the foundational timeline proposed by the Big Bang becomes questionable. This contradiction could imply that either our understanding of cosmic expansion is incorrect, or that the Big Bang might not have been the singular starting point of the universe. Moreover, the existence of these ancient galaxies necessitates a re-evaluation of how we understand cosmic evolution. The implications are vast and affect not just the timeline of the universe, but also the mechanisms by which galaxies grow and evolve. The very metrics we use to gauge the age and expansion of the universe could be flawed. This shift in understanding could be as significant as when Einstein's theory of relativity redefined the laws of gravity and motion laid down by Newtonian physics, presenting a new framework for understanding the universe. The discrepancies highlighted by JWST's observations are inviting astronomers and physicists to rethink not just the cosmic timeline, but also the very fabric of cosmological principles. We are potentially on the brink of a paradigm shift, where our old models may no longer suffice to explain the new evidence unfolding before us. This is a thrilling time in cosmology, as each new image from the JWST could be the key to unlocking a new understanding of the cosmos. Time may not exist. As we dive deeper into the cosmos with the James Webb Space Telescope, we're not just challenging scientific understandings, we're also venturing into the profound philosophical implications of these discoveries. The notion that time might be an illusion is gaining traction among some of the world's leading physicists. This idea suggests that what we perceive as time, a linear progression from past to future, is not a fundamental part of the universe, but rather a human construct. This perspective is radically different from our everyday experience and prompts a re-evaluation of everything we know about the flow of events. Enter the block universe theory, a compelling alternative that posits past, present, and future as existing simultaneously. In this model, time doesn't flow. Instead, it's an additional dimension, like space. Imagine a universe where every moment is as real and concrete as any point in space. This means that every event, whether it's the signing of the Declaration of Independence or your last birthday, isn't past or forthcoming, but perpetually exists in a vast four-dimensional space-time continuum. This theory aligns with Einstein's theory of relativity, which tells us that time and space are intertwined and relative. The implications are monumental. If the block universe is real, it challenges our understanding of causality. Cause and effect might just be an illusion, crafted by our brains to make sense of our observations. In such a universe, the idea of change itself might be an illusion, since everything is already laid out in the space-time fabric. These philosophical inquiries not only deepen our understanding of the universe, but also ask us to rethink our existential narratives. What does it mean for free will, for our plans, hopes, and fears, if the future is already written and unchangeable? As we continue to explore these questions, we must remain open to the idea that the universe might be far stranger and more mysterious than we could have ever imagined. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
For centuries, our gaze has been drawn upwards to the mysteries of the cosmos, pondering what lies beyond the glittering veil of stars. Today, the James Webb Space Telescope, JWST, stands at the helm of cosmic exploration, ushering us into a new era of discovery. This marvel of technology, equipped with the most advanced instruments, is poised to unravel the secrets of the universe. But what have these new eyes in the sky revealed? How might these groundbreaking discoveries reshape our understanding of the cosmos? Join us as we delve into the revelations of the James Webb Space Telescope and ponder the profound questions they raise about our place in the universe. The James Webb Space Telescope, often referred to simply as JWST, represents a significant leap forward in our ability to observe the cosmos. Launched in December 2021, this telescope is often hailed as the successor to the iconic Hubble Space Telescope. While Hubble has served us incredibly well, JWST is designed to surpass its predecessor with a suite of advanced technologies and instruments. Equipped with a large primary mirror that spans 6.5 meters across, considerably larger than Hubble's 2.4 meters, JWST can collect more light and observe objects in far greater detail. This larger size allows it to look deeper into space and further back in time, giving astronomers a clearer view of the early universe. One of JWST's most notable advancements is its ability to observe primarily in the infrared spectrum. This capability is crucial because it allows the telescope to see through cosmic dust clouds that obscure other wavelengths of light. By doing so, JWST can reveal hidden regions of space and provide new insights into the formation of stars, galaxies, and planetary systems. The mission objectives of JWST are broad, yet profoundly significant. They include unraveling the mysteries of our solar system, exploring distant worlds around other stars, and probing the mysterious structures and origins of our universe and our place within it. Each of these objectives not only sets the stage for a deeper understanding of the cosmos, but also ensures JWST's role as a cornerstone of astronomical research for the foreseeable future. Now let's dive into the concept of the observable universe and what that really means for us on Earth. The observable universe includes everything that we can see from our vantage point here on Earth, whether through the naked eye or with the most advanced telescopes like the James Webb Space Telescope. It's important to note that when we talk about the observable universe, we're really talking about the portion of the universe from which light has had enough time to reach us since the beginning of the cosmic timeline, the Big Bang, which happened about 13.8 billion years ago. This brings us to the mind-boggling scale of the observable universe. It measures about 93 billion light-years in diameter. Now, a light-year isn't a measure of time, but of distance. It represents the distance that light can travel in 1 year, which is approximately 5.88 trillion miles, or about 9.46 trillion kilometers. To put this in perspective, imagine light traveling at about 670 million mph, which is roughly the speed of light, and covering that enormous distance in a year. So when we say the observable universe is 93 billion light-years across, we're saying that it spans a distance of about 546.84 billion trillion miles, or 878.58 billion trillion kilometers. This immense scale helps us grasp just how vast the cosmos really is, filled with galaxies, stars, and other celestial phenomena, each of which could hold countless mysteries waiting to be uncovered. In the early 20th century, our understanding of the universe underwent a dramatic transformation thanks to Albert Einstein and Edwin Hubble. In 1915, Einstein introduced his theory of general relativity, which radically changed how we understand gravity. Unlike Newton's view of gravity as a force acting at a distance, Einstein described it as the effect of curvature of spacetime caused by mass and energy. This groundbreaking theory led to the realization that the universe isn't static but is, in fact, in motion. This theoretical framework set the stage for a pivotal observation by Edwin Hubble in 1929. Hubble discovered that galaxies are moving away from us, and crucially, the farther a galaxy is, the faster it appears to be receding. This phenomenon indicated that the universe is expanding, a concept that was initially counterintuitive even to Einstein. The tool central to understanding this expansion is the concept of redshift. Redshift occurs because as the universe expands, the light from distant galaxies is stretched along with the space through which it travels. This stretching shifts the light towards the red end of the spectrum, hence the name redshift. By measuring how much the light from the galaxy has been redshifted, astronomers can determine how fast it is moving away from us. This not only confirms the expansion of the universe, but also helps in estimating the rate of that expansion. Through these observations, redshift has become a fundamental aspect of cosmological research, allowing us to peer back into the universe's history and better understand its dynamic nature. As we gaze into the cosmos, one of the most intriguing questions we encounter is, what lies at the edge of the observable universe? The observable universe includes everything we can see from Earth, measuring out to about 93 billion light-years in diameter. But what exists beyond this boundary? Theories about the universe's edge often delve into complex and fascinating ideas about the nature of the cosmos itself. One popular theory suggests that the universe might be infinite. If this is true, it means there is no actual edge in the way we might traditionally imagine. Space could extend endlessly, containing an infinite number of galaxies and celestial phenomena, all interwoven in the fabric of the cosmos. Alternatively, some theorists propose that the universe is finite but without any edges or boundaries. This model suggests that space curves back on itself, much like the surface of a sphere. In this scenario, if you could travel far enough in one direction, you might eventually return to your starting point, traversing the universe much like circumnavigating the globe. This concept challenges our perceptions and highlights the extraordinary complexity and beauty of the universe. Both theories showcase human curiosity and our pursuit of understanding the universe's vast scale and form, providing a framework to explore the cosmos further with advanced technologies like the James Webb Space Telescope. The James Webb Space Telescope has once again turned our understanding of the cosmos on its head with its latest discoveries. Among the most startling revelations are the observations of 6 massive galaxies that existed surprisingly early in the universe's history, between 500 million and 700 million years after the Big Bang. Prior to these findings, scientists expected this era to contain only small, fledgling galaxies. The existence of such large galaxies so soon after the Big Bang poses a significant challenge to our existing models of galaxy formation. These galaxies, each comparable in mass to our 13-billion-year-old Milky Way, contain mature red stars, suggesting that they developed far more rapidly than any models had predicted. This rapid maturity contradicts previous assumptions that galaxies in the early universe started as small conglomerations of stars and dust, which gradually grew over billions of years. The James Webb Space Telescope, through its deep-field imaging capabilities, not only captured these galaxies, but provided data that has left astronomers reeling. These findings compel astronomers to revisit and possibly revise our understanding of cosmic history, particularly how galaxies and structures came into being so shortly after the universe's birth. This breakthrough demonstrates the JWST's unmatched capacity to expand our understanding of the early universe, adding depth to our knowledge of galaxy formation and challenging existing scientific theories. The James Webb Space Telescope, JWST, represents a significant leap forward in astronomical technology, equipped with state-of-the-art instruments designed to peer deeper into the cosmos than ever before. Among its most notable features is its suite of infrared capabilities, which allow it to observe the universe in wavelengths of light invisible to the human eye. This is crucial because infrared light can penetrate cosmic dust clouds that often obscure other forms of radiation. One of JWST's primary tools is its powerful infrared cameras. These cameras are essential for observing the early universe, as they capture images of celestial objects whose light has been stretched into the infrared spectrum by the expanding universe. This stretching, known as redshift, is more pronounced in objects that are farther away, meaning that JWST's infrared cameras can see further back in time than those of any previous telescope. In addition to its cameras, JWST is equipped with spectrographs that add another layer of observational power. Spectrographs are instruments that split incoming light into its component colors or wavelengths. This allows astronomers to analyze the properties of that light, including its composition, temperature, and motion. By studying the spectral lines in these light signatures, scientists can determine the chemical composition of distant stars and galaxies, uncovering details about their age, mass, and even potential for planets. Moreover, the telescope's use of coronagraphs a technology designed to block out the blinding light of stars, enables the direct observation of nearby exoplanets and other faint objects around those stars. This combination of advanced instruments makes JWST uniquely capable of studying the formation and evolution of stars, galaxies, and planetary systems, providing a window into processes that occurred billions of years ago, only a few 100 million years after the Big Bang. In a recent groundbreaking discovery by the James Webb Space Telescope, astronomers have uncovered evidence of 6 massive galaxies that existed surprisingly early in the universe's history, between 500 million and 700 million years after the Big Bang. This revelation is particularly startling because prior to this, scientists had only expected to find small, nascent galaxies at such an early stage in cosmic history. The presence of these large, mature galaxies so soon after the Big Bang poses significant challenges to our existing theories of how galaxies form and evolve. Traditionally, astronomers believed that galaxies started small and gradually grew larger over billions of years through processes such as star formation and mergers with other galaxies. However, the discovery of these universe-breaker galaxies, as they have been aptly nicknamed, suggests that galaxy formation might occur more rapidly and differently than previously thought. Each of these galaxies appears to be as large and as mature as our own Milky Way, which is roughly 13 billion years old. This unexpected maturity of galaxies and what can be considered the cosmic dawn forces astronomers to reconsider the physics of early universe galaxy formation. It suggests that significant amounts of star formation must have happened very quickly to allow these galaxies to reach such a mature state so early on. These findings not only raise questions about the speed and process of galaxy formation, but also hint at the possibility that the conditions in the early universe might have been different from what the current models suggest. Now let's look at what the future holds. As we continue to push the boundaries of our cosmic knowledge, the future of space exploration looks brighter than ever, thanks to upcoming missions and advanced telescopes. A particularly exciting development is the planned launch of the Nancy Grace Roman Space Telescope, formerly known as the Wide Field Infrared Survey Telescope, or WFIRST. Scheduled for launch in 2027, this telescope will carry on the legacy of the James Webb Space Telescope by delving even deeper into the mysteries of the cosmos. The Roman Space Telescope is designed to explore various fundamental questions in the fields of dark energy, exoplanets, and infrared astrophysics. With a primary mirror diameter of 2.4 meters, identical to that of the Hubble Space Telescope, the Roman Space Telescope will offer a new perspective on the universe. Its wide-field instrument will allow it to capture images over a field of view more than 100 times larger than that of the Hubble, enabling it to survey the sky at unprecedented scales. This will not only increase our ability to observe the cosmos, but will also dramatically enhance our understanding of the universe's structure and evolution. Moreover, the Roman Space Telescope will be equipped with a coronagraph instrument, which is specifically designed for high-contrast imaging and spectroscopy of nearby exoplanets. This instrument will be crucial for blocking out the overwhelming glare of stars, allowing the telescope to directly image exoplanets. Such capabilities are expected to revolutionize our insights into planetary formation and offer new possibilities for studying potentially habitable planets. By building on the discoveries made by the JWST, the Roman Space Telescope will extend our cosmic reach, bringing us closer to answering some of the most profound questions about our universe. This seamless integration of past achievements with future potential underscores the dynamic and ever-evolving nature of astronomical exploration. In summary, the advent of the Nancy Grace Roman Space Telescope marks a significant milestone in our ongoing quest to understand the cosmos. By leveraging cutting-edge technology and building upon the foundation laid by the James Webb Space Telescope, this new mission promises to expand our horizons further, offering deeper insights into the universe's secrets and potentially uncovering new realms of knowledge in dark energy, exoplanets, and beyond. As we look to the future, the potential for discovery seems limitless, promising a new era of astronomical breakthroughs. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now. Imagine traveling billions of kilometers into the uncharted region of space to a place where storms the size of Earth churn through an icy blue atmosphere and winds howl at unimaginable speeds. Greetings from Neptune, the far-off enigmatic giant of our solar system that enthralls and confounds astronomers worldwide. This ice giant is like something out of a science fiction book, especially with its mysterious moon Triton. Yet the realities we've only just started to learn about dwarf even our most fantastical fantasies. Deeper exploration of Triton's frozen mysteries and Neptune's flowing mysteries raises issues that cast doubt on our comprehension of the cosmos. Why is the internal engine of Neptune so strong that it can overcome the frigid darkness of its far orbit? And can Triton, with its geologic activity and retrograde motion, hold secrets beneath its frozen crust that change our perception of possible extraterrestrial life sites? Come along as we investigate these and other issues while delving into one of the solar system's most intriguing frontiers. Voyager 2 reached its closest approach to Neptune in August 1989, completing a historic chapter in space exploration and the spacecraft's last planetary encounter. This was also a major turning point in the Voyager mission. Voyager 2's mission to sweep by Neptune yielded incredible photos and priceless data, illuminating a world of vivid blue hues, spinning clouds, and complex weather systems never before seen by human eyes. In addition to providing us with our first up-close looks at Neptune, this flyby provided important new information about the planet's magnetic field, atmosphere, and fascinating array of moons surrounding it. Unexpected information about Neptune's tumultuous atmosphere was uncovered by the data, including the identification of the Great Dark Spot, an anticyclonic storm similar to Jupiter's Great Red Spot. The meeting brought to light some of Neptune's oddities, like its extraordinarily strong weather patterns and the solar system's greatest wind speeds, which may reach 1/600 miles per hour. Voyager 2's visit to Neptune significantly altered our knowledge of the outer solar system, igniting current research projects and posing fresh queries for upcoming expeditions. Neptune is one of the more remarkable planets in our solar system based on some rather astounding numbers. Neptune draws attention because it is the fourth largest planet in terms of diameter, but it has other noteworthy characteristics as well. It is the largest and densest ice giant in terms of bulk as well. Only Uranus belongs to this category, which emphasizes planets mostly made of more volatile materials like water, ammonia, and methane, surrounded by an atmosphere of hydrogen and helium. But how does Neptune fit in with the other planets? The planet is a monster both in terms of its physical presence and gravitational force, because it is an astounding 17 times larger than Earth. Its enormous size helps to distinguish it from gas giants like Jupiter and Saturn, which are primarily made of hydrogen and helium, and earns it the designation of ice giant. Because of its large mass and density, Neptune may have a complex interior structure with habitats that are very different from Earth's or any other planet in our solar system due to pressures and temperatures. Because of its distinct set of characteristics, Neptune is a fascinating object to study for planetary science, as well as for learning about the dynamics of other exoplanets in our galaxy that are comparable to it. In Neptune's stellar neighborhood, Triton is a massive object both in terms of size and the amount of gravitational pull it possesses. This moon is the heavyweight champion of the Neptunian system, containing more than 95.5% of the mass orbiting Neptune. When Triton was first identified in 1846 by British astronomer William Lassell, it stood out from other moons in our solar system as well as those of Neptune. Triton is unique in that it rotates in the opposite direction of Neptune, because to its odd retrograde orbit. This strange motion suggests a tumultuous history, possibly signifying that Triton did not develop alongside the planet Neptune, but rather was ensnared by its gravity. Triton's active geology, which is remarkably vivid for a moon so far from the sun, supports this view. Triton's cryovolcanism depicts a dynamic living world beneath its frozen exterior. Driven by heat from the moon's interior, plumes of nitrogen gas burst through the surface, indicating the presence of geological processes akin to those on Earth's own volcanically active bodies. This action may indicate the existence of an internal heat source that maintains a portion of Triton's subsurface ocean liquid, providing a tantalizing glimpse into potentially habitable circumstances. Buried behind ice sheets, such an ocean would not only transform our knowledge of Triton, but also hold secrets regarding the moon's origins and development. Even the most experienced astronomers are baffled by the mystery surrounding Neptune. Despite being 4.5 billion kilometers away from the sun, this frozen monster is able to release twice as much energy as it takes in. The riddle is further compounded by the fact that Neptune's atmosphere is actually home to some of the most violent weather systems in our solar system, rather than being a peaceful sea of blue. Here, the winds are not merely gentle breezes, they may reach speeds of up to 2,000 km/h. However, what may be causing such severe weather? The solution is buried deep within Neptune. Neptune is dependent on an internal heat source in contrast to Earth, which receives the majority of its energy from the sun. Although the exact source of this heat is unknown, scientists believe that gravitational contraction, or the steady compression of the planet's own material, may be the cause. On the other hand, the planet's core radioactive element decay could be the source of the heat. Uncovering the mystery of Neptune's interior energy, which powers enormous winds and massive storms, is essential to understanding not only the atmospheric dynamics and internal workings of exoplanets around the cosmos, but also the riddles surrounding this far-off planet. The scientific world has taken notice of a number of atmospheric oddities that Neptune has displayed in recent years. These include the enduring storm systems and enigmatic dark patches, which are uncannily similar to Jupiter's notorious Great Red Spot. Neptune's storms are enormous and long-lasting, showing a more tumultuous aspect of this far-off planet than the transient, unpredictable weather patterns we're used to on Earth. And classic example of a storm was one that was seen during the Voyager 2 flyby in the late 1980s. This enormous storm system, also called the Great Dark Spot, was as big as Earth. Interestingly, this storm disappeared and was replaced by other comparable places in different parts of the Earth when astronomers searched for it later using the Hubble Space Telescope. Significant queries concerning the genesis and life cycle of Neptune's storms are brought up by their fleeting character. What causes these enormous storms? The reason could be found in Neptune's interior heat, which is unusually powerful given the planet's enormous distance from the Sun. Compared to its solar radiation, Neptune releases a large amount of energy, indicating the presence of an internal mechanism that may be connected to the quick condensation of ammonia, hydrogen sulfide, and methane in the atmosphere. Moreover, Neptune's dark areas are believed to be anticyclonic systems, just like their Jovian counterpart. Without direct observations, much of the dynamics of these systems, including how they arise and why they dissolve, is still hypothetical. Nonetheless, the fact that they exist indicates how dynamic and active Neptune's atmosphere is, which forces scientists to reconsider atmospheric research on massive planets. Our knowledge of planetary atmospheres generally, even those outside of our solar system, is influenced by research on Neptune's atmosphere. Neptune is a fascinating contender in the search for possible homes beyond Earth. This enormous planet's vast size suggests that there may be room for human existence or colonization. Scientists are fascinated by Neptune's potential because of its abundant water supplies that are hidden beneath layers of ice, despite its harsh and unforgiving conditions. In addition to encouraging survivalist ideas, the prospect of using these water supplies sparks debates over whether life is possible in such harsh, far-off places. It's true that Neptune is hostile right now, with its strong winds and icy temperatures, but scientists are still debating what might happen in the future. Is it possible that technological progress may eventually enable humans to alter these settings, or at least establish livable areas inside them? Furthermore, given its vast size, the planet may be able to sustain a population, assuming that strategies for withstanding or adapting to its harsh environments are created. With the development of increasingly advanced space-based observatories, our dependence on ground-based telescopes has drastically changed in our quest to understand the mysteries of Neptune and its fascinating moon Triton. Deeper observations of our solar system have been made possible by the Hubble Space Telescope, HST, and the more recent James Webb Space Telescope, JWST, which have provided previously unthinkable levels of clarity and detail. The 1990-launched Hubble Space Telescope, HST, has been a key instrument in the study of Neptune's dynamic atmosphere and intricate weather patterns. Because of its capacity to take high-resolution pictures, scientists have been able to track the development and evolution of storm systems on Neptune in real time. These findings have provided insight into the complex mechanisms underlying Neptune's tumultuous atmosphere. Let me introduce the James Webb Space Telescope, which will be launched in 2021 and will greatly advance our capacity for observation. The cutting-edge equipment of the JWST is intended to observe mostly in the infrared spectrum, which is essential for researching far-off astronomical worlds like Triton and Neptune. JWST can see through Neptune's dense cloud cover thanks to its potent array of detectors, offering previously unattainable insights into the planet's thermal characteristics and atmospheric makeup. Furthermore, studying Triton's surface and maybe subsurface seas is becoming increasingly dependent on the sensitivity and resolution of the JWST. The JWST analyzes light reflected off the icy crust of Triton to help astronomers learn more about its composition and to record events like cryovolcanic eruptions, which are thought to spew ammonia and water into space. As our cosmic eyes, space telescopes continuously send data that helps us learn more about the solar system and reveals the secrets of far-off worlds like Neptune and Triton. Neptune's immense distance from Earth makes it one of the biggest obstacles to contemporary astronomy and space exploration. Because of its extreme distance, roughly 4.5 billion kilometers, every expedition to Neptune is an enormous operation. Signals alone take more than 4 hours to go one way due to the great distance between our planet and Neptune, making real-time communication and spacecraft management difficult. The enormous distance has an effect on both the energy needed to transmit probes to and from Neptune, as well as the logistics of spaceflight. In order to reach Neptune, carry out scientific operations, and maybe return data to Earth, spacecraft must carry enough fuel. This necessitates meticulous planning and cutting-edge engineering to maximize paths and the scientific return on the energy expended. In addition, there are more challenges because of the harsh environment outside of our solar system. Highly effective thermal control and power systems are essential for spacecraft due to the extreme cold and limited solar energy accessible at such distances. The fact that radioisotope thermoelectric generators are used instead of solar panels illustrates the creativity needed to function in such a hostile environment. Every bit of information gleaned from Neptune's orbit is priceless because it sheds light on the planet and deepens our knowledge of the dynamics of the outer solar system, while demonstrating the inventiveness and rapidly developing technologies that propel space travel. NASA's ambitious ambitions for the future in space travel continue the quest to discover the secrets of our cosmic neighbors. The Neptune Odyssey is one of the most eagerly awaited missions. It could set off as early as 2031. This project offers a unique chance to explore deep inside Neptune and its mysterious moon Triton, going beyond a conventional flyby. The Neptune Odyssey seeks to perform a thorough investigation of Neptune and Triton, concentrating on their atmospheres, geology, and possible marine conditions. It does this by employing state-of-the-art equipment and careful preparation. This expedition offers a fascinating peek into the mysteries concealed within these far-off worlds, marking a substantial advancement in our understanding of them. Just picture the enthusiasm that is building among the engineers and scientists at NASA as they get ready for this historic voyage. A monument to human ingenuity and our never-ending hunger for knowledge. The Neptune Odyssey is the result of years of planning, investigation, and excitement. Many people who are eager to discover the secrets of Neptune and Triton are carrying with them the aspirations and dreams they have as the spaceship rockets through space. Every element of these celestial bodies, from the inside workings of their atmospheres to the geological characteristics scattered across their surfaces, will be examined with an unprecedented level of accuracy. In addition to advancing our knowledge of Neptune and Triton, the information acquired by the Neptune Odyssey will provide insight into the larger processes forming our solar system. We are getting closer to understanding the workings of our cosmos and may perhaps find hints of extraterrestrial life by solving the riddles of these far-off places. Let's sum up by saying that NASA's Neptune Odyssey mission is a critical step forward in humanity's exploration of the distant regions of our solar system. This enormous project, which focuses on Neptune and Triton, aims to solve long-standing puzzles and deepen our understanding of these far-off worlds. The Neptune Odyssey serves as a reminder of the limitless possibilities of human exploration and the unwavering spirit of discovery that propels us to push the boundaries of knowledge as we eagerly await the launch, which might occur as early as 2031. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
Imagine looking up at the night sky knowing that credible reports from military personnel and pilots over the past 2 decades have documented an eerie rise in unexplained aerial phenomena. The public's skepticism persisted until undeniable evidence was laid before the US Congress and confirmed by the Pentagon, forcing us to confront the unimaginable. Now, in a stunning twist, NASA has dropped a bombshell that edges us closer to unlocking the enigma of extraterrestrial life. What groundbreaking discovery has NASA made about an alien presence near Saturn? Prepare to be amazed as we delve into the latest revelation, a colossal 2,000-mile-long structure detected by a NASA probe moving ominously near Saturn. What does this mean for humanity's future? Join us on this cosmic journey to uncover the truth. The emergence of unidentified aerial phenomena, UAPs, has captivated the curiosity of countless individuals, sparking a collective desire to understand their inherent characteristics and assess any potential risks they may pose. While there are still those who dismiss the notion of extraterrestrial life as mere fantasy, the sheer number of reported sightings, UFO encounters, and various incidents and experiments we will delve into defy easy explanation. Recently, NASA, a renowned authority in space exploration, publicly acknowledged the discovery of a strange structure in motion near Saturn. This revelation aligns with the predictions made by notable experts, such as Israeli-American scientist Avi Loeb. Stay tuned to uncover all the juicy details about the 2,000-mile-long structure found on Saturn and the possibility of life existing on the planet. But first, let's examine some of the most compelling evidence supporting the existence of extraterrestrial life. The shocking claims of Robert Dean, former U.S. Army Command Sergeant Major Robert O. Dean, captivated audiences with his fascinating insights into alien contact, leveraging his military background to illuminate various interactions between extraterrestrial beings and humanity. The undeniable credibility of his claims was reinforced by his tenure at NATO headquarters from 1963 to 1967, during which he presented an assessment paper as a part of a NATO study on the repercussions of alien presence on Earth. It was during the commemoration of the 50th anniversary of the Roswell incident that he unveiled these remarkable revelations. In a riveting presentation at Leeds University, Major Dean disclosed that throughout his service, he was not only aware of one extraterrestrial group, but 4 distinct groups. Astonishingly, by the time of his retirement, this number had grown to over 12. What's even more astounding is that this awareness extended beyond the US military to include British military personnel. Major Dean hinted at the existence of over 100 separate alien organizations, each with enigmatic origins. This groundbreaking disclosure revolutionized our comprehension of extraterrestrial engagement and the intricate interplay between Earth and civilizations far beyond our own. One particular group of aliens captured the attention of military officials back in 1964. These beings closely resembled humans and effortlessly assimilated into society, being observed on aircraft, in restaurants, and even in theaters. Understandably, concerns were raised regarding their potential infiltration into influential institutions such as SHAPE headquarters and the Pentagon. Military officers reacted with a mix of amusement and anxiety at the prospect of these beings gaining access to the White House. Major Dean proposed a fascinating perspective, suggesting that humans shared striking similarities with these intelligent aliens, implying a profound connection between our species. He vaguely alluded to an undisclosed basis for this resemblance. Additionally, he unveiled that alien visitation extended beyond interactions between planets, encompassing encounters with interstellar and cosmic creatures. This non-human intelligence possessed multi-dimensional characteristics, exerting control over both matter and time, thus redefining our understanding of the universe. These aliens were not mere explorers, they were captivated by humans. Their multi-dimensional nature and mastery over time and matter posed a challenge to classical physics, necessitating the expertise of quantum physicists. The collaboration between American and British physicists demonstrated their unwavering commitment to unraveling this mystery. Major Dean, although not a scientist himself, acknowledged the dimensional complexity of these beings, referencing the theoretical physicist's notion of 10 dimensions. He embraced this reality based on accumulated evidence spanning 4 decades, emphasizing that it was not a mere work of science fiction, but rather an earth-shattering reality poised to profoundly transform our world. Major Dean proclaimed that the familiar world we had known for so long was teetering on the edge of extinction, with the impending impact of this revelation poised to reshape our thinking and pave the way for an unprecedented paradigm shift. At the Barcelona Ecopolitics Summit in 2009, Mr. Dean showcased a collection of awe-inspiring photographs offering unparalleled insights. Among these were images purportedly captured by Apollo 12 astronauts, featuring a mysterious spaceship hundreds of feet in diameter. His account of the Apollo missions and the astronauts' experiences diverged significantly from others, further heightening the intrigue surrounding his revelations. The breadth of Major Dean's claims left even him momentarily speechless. Despite his years of exposure to the extraordinary during his 41 years of service to the United States, he asserted that humanity has maintained an intimate interrelationship with advanced extraterrestrial intelligence since the dawn of our history, and according to him, this profound interplay continues to this day. Major Dean contended that one particular alien race had played a role in re-engineering humanity as a species approximately 200,000 years ago, resulting in the Homo sapiens that we are today. He emphasized that we, as a product of their craftsmanship, have had our genetics tampered with. Major Dean's stature as a prominent figure in ufology was duly recognized through the receipt of 3 Lifetime Achievement Awards, and his contributions to the field continue to shape the ongoing debate surrounding extraterrestrial involvement in human history. Although Mr. Dean passed away in 2018, his legacy endures. Kensington UFO sighting. Are you prepared to handle the shock that would come from an encounter with an alien? This perplexing event happened off the coast of Prince Edward Island. Our story begins with John Shepard, an ordinary man whose life took an extraordinary turn one fateful June evening in 2014. Picture a serene night at Twin Shores campsite near Kensington as the clock struck 11:30. Little did Shepard know that his world was about to be dramatically altered. Caught in the enchanting allure of the night, Shepard's gaze was inexplicably drawn to a diamond-shaped light shimmering above the vast sea. It was as though he had stumbled upon a scene straight out of a science fiction tale. This mysterious light, positioned approximately 75 meters from the shore and nearly a kilometer away, performed a mesmerizing dance, captivating Shepard's undivided attention. Driven by his instincts, Shepard swiftly retrieved his phone and commenced filming the otherworldly event, providing a running commentary on what could only be described as an extraordinary light show. Suddenly, a second light appeared, 3 minutes after the first, leaving Shepard bewildered and exclaiming, "I've never seen anything like it," hoping his footage would reveal details unseen by the naked eye. He feared being labeled a lunatic. Over a year later, the encounter still baffled him, as he confessed in an interview, unable to compare the lights to anything familiar. Seeking answers, he hid behind a bush, taking photos of the spectacle until the lights vanished after 8 minutes, leaving him with lingering questions and curiosity. In his quest for answers, Shepard reached out to the Mutual UFO Network of Canada, a reputable non-profit organization dedicated to investigating such phenomena. Sharing his footage, Shepard hoped they could unravel the enigma. The network, known for its thorough approach, took his case seriously. Assistant Director Stu Bundy and his team diligently examined the evidence, using sophisticated technologies to explore potential explanations. Despite their efforts, the bright lights captured by Shepard remained unidentified, defying conventional explanations like star patterns or the International Space Station. The network's drone experts also cast doubt on a drone being responsible, considering the strong winds that night and the existence of 2 distinct objects. After an exhaustive investigation, the network unveiled its findings. Shepard had indeed witnessed a genuine unidentified aerial vehicle. Assistant Director Stu Bundy couldn't contain his amazement at the rarity and significance of this sighting. However, this event didn't shock the public like the recent 2,000-mile-long structure found on Saturn. Former NASA engineer Dr. Norman Berggren, in his groundbreaking 1986 book, Rainmakers of Saturn, claimed that alien spaceships exist within our solar system and play a remarkable role in the formation of planetary rings, particularly those around Saturn. Berggren suggested these extraterrestrial vessels are not confined to Saturn alone, but also extend to other ringed planets like Jupiter and Uranus, hinting at a widespread cosmic interaction. He proposed that these enormous alien vehicles known as ringmakers may have helped form certain sections of Saturn's majestic rings. Berggren's claims, made in 2016, suggest that long cylindrical objects with exhaust systems and other features reside within Saturn's rings. These observations challenge conventional beliefs and prompt a reassessment of our understanding of the universe and extraterrestrial interactions. Berggren asserts that these massive living alien UFO spaceships are multiplying rapidly on Saturn's rings, posing a significant threat. According to his book, Rainmakers of Saturn, these spacecraft not only exist, but are proliferating at an alarming rate, using the rings for energy and concealment. He describes them as autonomous, self-reproducing entities that blend seamlessly with their cosmic surroundings, sparking intense debate about advanced alien civilizations exploring our solar system. Berggren's allegations challenge the mainstream scientific consensus, but find support among UFO researchers and enthusiasts who believe they reveal a well-kept NASA secret, with some speculating that NASA has concealed evidence of extraterrestrial exploration to avoid widespread panic or geopolitical unrest. His credibility is bolstered by his background in highly classified aerospace programs at Lockheed Martin and his service on the National Advisory Committee for Aeronautics, though his statements remain debated and lack huygens scientific support. The remarkable Cassini spacecraft from 2004 to 2017 explored Saturn and its rings in the Cassini-Huygens mission, a collaborative effort between NASA, the European Space Agency, and the Italian Space Agency, yielding groundbreaking discoveries and pushing the boundaries of our understanding, with notable revelations continuing nearly 6 years after the mission's conclusion. The expedition began over Kraken Mare, a 680-kilometer expanse on Saturn. The spacecraft then advanced toward Ligea Mare, another vast sea. As the journey continued, Cassini's radar collected data over smaller lakes, each about 30 miles wide. This exploration led to a remarkable discovery: phosphate within the hidden ocean of Saturn's moon, Enceladus, as published in the journal Nature. Additionally, Cassini's dust analyzer found ice grains and water vapor from Enceladus's cryovolcanic plumes, revealing high concentrations of sodium phosphates and phosphorus, surpassing Earth's ocean levels by 100-fold. Phosphorus, vital for life, was found in Enceladus's ocean beneath its icy surface. This molecule, essential for cell membranes, DNA, and RNA, suggests potential habitability. Professor Frank Postberg of Freie Universität Berlin, the study's lead author, called it an extraordinary discovery, the first phosphate found in an extraterrestrial ocean. However, Dr. Christopher Glein of the Southwest Research Institute urges caution, noting that life's elements are only part of the equation. During the planet's equinox on August 11th, the NASA Cassini spacecraft uncovered a new mystery in Saturn's rings. As sunlight illuminated the rings, Cassini captured an extraordinary event: a small moonlet casting an elongated shadow across Saturn's B ring. This moonlet, about 1,300 feet in diameter, created a striking shadow 25 miles wide. Cassini's perfectly timed encounter, coinciding with the rare equinox that occurs once every 15 years, provided a captivating spectacle on the cosmic stage. The strategic planning of this cosmic rendezvous allowed the spacecraft to witness Saturn's equator illuminated by the sun's rays, creating a captivating display. During the 27 months of equinox, the sun's light directly bathes Saturn's equator, causing any three-dimensional object within the rings to cast a striking elongated shadow. While some speculate these shadows could be alien spaceships, such claims remain unproven. The Cassini spacecraft, with its advanced instruments and cameras, captured this event with precision, providing scientists with invaluable insights into Saturn's enigmatic rings. The intricate interplay of light and shadow, as the small moonlet cast its elongated silhouette, added yet another layer of intrigue to our evolving comprehension of this captivating planetary system. Saturn's resplendent rings have long held astronomers and space enthusiasts in a state of fascination and bewilderment. The intricate dynamics at play within this celestial jewelry box continue to captivate our collective imagination, while the exact origins and composition of Saturn's rings remain subjects of ongoing scientific investigation. Discoveries like Cassini's observation during the equinox offer tantalizing glimpses into the concealed mysteries that lie within. a surprising photograph has surfaced showing a black triangle UFO emerging from the ocean, reportedly taken by a U.S. Navy pilot. This image has sparked intense speculation among UFO enthusiasts. While the Pentagon has not confirmed its existence, insiders hint at its authenticity. In a 2020 interview, Luis Elizondo, former head of the Advanced Aerospace Threat Identification Program, mentioned this photo. He revealed that the Unidentified Aerial Phenomena (UAP) Task Force had a collection of photos of unexplained aerial objects, including this triangle. These encounters, involving large triangles with rounded edges and bright lights at each corner, allegedly occurred off the east coast of the U.S., with pilots from the USS Dwight D. Eisenhower and the USS John C. Stennis. The connection between UFO sightings and nuclear capabilities has long fueled conspiracy theories. With reports of the existence of this photograph, several officials have acknowledged its presence but have refrained from providing any further information. According to sources, the UAP task force primarily focuses on investigating unidentified submersible phenomena or transmedial objects capable of traversing both the underwater and aerial realms. Speculation suggests that these enigmatic crafts may have originated from the world's oceans. Tom Rogan, a national security journalist for the Washington Examiner, independently verified the existence of this photograph through his sources. He asserts that this snapshot merely scratches the surface, hinting at the existence of additional classified UAP imagery and intelligence that may be unveiled in the coming years. Rogan ardently advocates for the formal release of new materials from the Pentagon in the hopes of shedding light on even more intriguing details. The term unidentified submersible objects is not a novel concept within the UAP task force's investigation. There have been instances of highly advanced sonar systems detecting high-speed encounters with underwater objects. Even a senior intelligence official specializing in underwater surveillance acknowledges the authenticity of accounts regarding the presence of ultra-fast underwater objects as identified by U.S. military systems. While the task force's emphasis on investigating transmedium vehicles may strike some as unusual, throughout history there have been numerous instances of unidentified objects effortlessly maneuvering in and out of water. Astoundingly, first-hand encounters with these mysterious underwater objects have been reported. Mark D'Antonio, an astronomer and lead video and image analyzer for the Mutual UFO Network, recounted a remarkable experience during which an underwater fast mover was discovered while sailing aboard a U.S. Navy assault submarine. Additionally, Tyler Rogaway, a defense writer, delved into the mystery of high-speed sonar targets with a group of seasoned submariners, further bolstering the compelling evidence. While skepticism remains, Navy veterans with first-hand experience affirm the veracity of these incidents. An intelligence official acknowledges their presence but remains tight-lipped due to the sensitive nature of underwater reconnaissance. Andrew McGrillen of UAP Media UK recounts a fascinating incident involving a triangular object that ascended from underwater to an altitude of 35,000 to 40,000 feet, captured in a high-fidelity photograph. McGrillen believes releasing this image could provide crucial evidence that we are not alone in the universe. Luis Elizondo, a prominent UFO researcher, claims to have seen a photograph or video still of a triangle-shaped UFO emerging from the ocean. He commends Senator Marco Rubio for discussing UFOs openly and, with the National Academy for the Phenomenon, NAPE, explores the extensive scope of the phenomenon. Elizondo highlights the limitations of government programs, such as their inability to engage commercial pilots and thoroughly investigate sightings. He anticipates greater public disclosure and the reduction of UFO stigma. He hints at an upcoming video showcasing a triangle-shaped UFO with unprecedented clarity and detail. In a remarkable disclosure, Bob McGuire, a former covert intelligence officer, shares two first-hand experiences with submerged UFOs or unidentified submerged objects, USOs. This follows a 2019 U.S. military video showing an unidentified object transitioning from sky to water, further contributing to the growing body of evidence. Testimonies and evidence from individuals like McGrillen, Elizondo, and McGuire depict encounters with unidentified objects in both air and water. These accounts, supported by photographs, videos, and leaked documents suggest a technologically advanced presence beyond our understanding. As public discourse on UFOs continues, we move closer to uncovering the secrets beyond our planet. Thanks for watching another episode of A World to Discover. While you're still here, click on the other videos you see on your screen right now. Betelgeuse, the colossal red supergiant blazing at the shoulder of Orion, just experienced a staggering 150% surge in brightness, an enigmatic pulse that has astronomers buzzing with excitement. This cosmic titan has a history of erratic behavior, with recent outbursts suggesting it could be on the brink of a supernova explosion. But when will it happen? What does this mean for our understanding of the universe? As we delve into the mysteries surrounding this giant, we'll uncover how Betelgeuse's unprecedented brightness changes are rewriting what we know about stars and bringing us closer to an astronomical spectacle that could light up our sky for weeks. The recent brightening surge. In a recent and stunning astronomical event, the James Webb Space Telescope has captured a significant increase in the brightness of Betelgeuse, one of the most well-known stars in our night sky. This red supergiant, typically noted for its steady glow on the shoulder of the Orion constellation, has recently surged to become the 7th brightest star visible from Earth. The brightness of Betelgeuse has peaked at an astonishing 150% above its usual luminosity. This sudden and unexpected brightening of Betelgeuse offers a unique spectacle for both amateur stargazers and professional astronomers. Positioned in a constellation familiar to many, its enhanced brilliance makes it an even more striking feature in the night sky. The increased brightness is not just a trivial change. It represents significant and dynamic processes occurring in the star's life cycle. Such a surge in luminosity could be linked to changes in the star's surface temperature, size, or radiative processes, showcasing the unpredictable nature of these celestial giants. As the star currently ranks as the 7th brightest, its prominence in the sky is a call to observers and scientists to watch closely. Each observation and data point collected helps in piecing together the complex life story of stars like Betelgeuse. The James Webb Space Telescope, with its advanced capabilities, continues to monitor these changes, providing crucial insights into the behavior of stars on the brink of their evolutionary shifts. This event not only enriches our understanding of stellar dynamics, but also enhances the nightly spectacle for skywatchers around the globe. Supernova anticipation. As the enigmatic red supergiant Betelgeuse continues to dazzle stargazers and astronomers alike, anticipation is mounting over the possibility of it going supernova, a stellar explosion that could offer a spectacle unlike any other seen in our lifetimes. Betelgeuse, a behemoth star nearing the end of its life, has sparked a wave of speculation due to its unusual and dramatic fluctuations in brightness. This has led many to wonder, are we on the brink of witnessing a supernova? Experts in the field are closely monitoring Betelgeuse, predicting that it might explode into a supernova within the next few decades. This potential timeline, however, contrasts starkly with NASA's more conservative estimate, which suggests that Betelgeuse's supernova event may not occur for another 100,000 years. This disparity in predictions underscores the complexities and uncertainties inherent in studying such colossal celestial phenomena. The prospect of Betelgeuse's supernova has not only captivated the scientific community, but has also permeated popular discussions. The idea that we could soon witness one of the most significant events in our galaxy, an event so bright that it could outshine the moon and be visible during daylight hours, stirs a blend of excitement and awe. This anticipation is further fueled by our limited understanding of supernovae, as each observation provides critical data that can redefine what we know about the life cycle of stars. Thus, the watchful eyes of the world remain fixed on Betelgeuse, eagerly awaiting any signs that may hint at its imminent transformation. Whether this spectacular event occurs in the near future or millennia from now, the ongoing study of Betelgeuse offers invaluable insights into the final days of a star's life. Historical brightness patterns. Betelgeuse's erratic luminary ballet has fascinated skywatchers across the millennia. From the indigenous Australians to the ancient Greeks, the star's periodic brightening and fading have been meticulously observed and documented, embedding Betelgeuse deeply into cultural lore and astronomical study alike. Traditionally, this red supergiant exhibited a predictable brightness cycle lasting approximately 400 days. However, recent observations have painted a different picture, revealing a shift to a much shorter 130-day cycle. This significant change in Betelgeuse's behavior marks an atypical deviation from its historic patterns. What could possibly cause such a dramatic alteration in its cycle? This question captivates astronomers and adds a layer of mystery to an already enigmatic celestial body. The shift suggests an underlying change in the star's internal processes or external influences that we are yet to fully understand. The implications of these rapid cycles are profound, both for our theoretical understanding of stellar physics and for the practical monitoring of Betelgeuse. As we continue to observe this star, each cycle of brightening and dimming could bring us closer to unraveling the secrets of its celestial mechanics and perhaps predicting its ultimate fate. For now, the rapid changes serve as a celestial puzzle, connecting the curiosity of ancient civilizations with the high-tech investigations of modern astronomy. The Great Dimming Event. In late 2019, the astronomy community was abuzz as Betelgeuse, one of the most well-known stars in the night sky, began to exhibit some highly unusual behavior. This red supergiant star, famous for its brilliant reddish hue and prominent position in the Orion constellation, unexpectedly dimmed by an astonishing 60%. This phenomenon, quickly dubbed the Great Dimming, sparked a wave of speculation among scientists and stargazers alike, many of whom wondered if Betelgeuse was about to go supernova. The dimming was so significant that it was clearly visible even to casual observers, marking a stark change from the star's typically bright appearance. The sudden shift led to numerous theories about the star's imminent death and transformation into a supernova, which would have been a spectacle visible across vast distances in the galaxy. However, as astronomers monitored the star more closely using the world's most advanced telescopes, a different explanation emerged. It was discovered that the Great Dimming was not a sign of impending supernova, but rather the result of a colossal surface eruption on Betelgeuse. This massive explosion had expelled a significant cloud of dust away from the star's surface. The cloud was large enough to obscure the light coming from Betelgeuse, leading to its dramatically reduced luminosity as observed from Earth. This finding was crucial as it not only provided a rational explanation for the dimming, but also offered a rare insight into the kinds of surface activities that can occur on red supergiants like Betelgeuse. The Great Dimming served as a reminder of the dynamic and ever-changing nature of stars, regardless of their age or size. It highlighted the complex interplay of forces operating in these colossal celestial bodies, and how they can lead to spectacular, if misunderstood, events that can momentarily trick us into believing that a star's end is near. Moreover, this episode allowed astronomers to study the mechanisms behind such massive ejections and how they affect the star's behavior and evolution. Understanding these processes is vital for predicting the life cycles of similar stars and preparing for the actual supernova events that one day will light up our skies. Star size and structure. Imagine, if you will, placing Betelgeuse at the center of our solar system. This colossal red supergiant would not merely loom large in our sky. It would engulf it, extending beyond Mars and reaching all the way past Jupiter. This staggering size isn't just for show, it fundamentally affects how Betelgeuse behaves as a star. Betelgeuse is classified as a red supergiant, a type of star that has exhausted the hydrogen in its core and expanded massively as a result. The sheer scale of Betelgeuse can be hard to comprehend. In comparison, if our Sun, a mere speck in size against the backdrop of Betelgeuse, were to suddenly expand to the red supergiant's proportions, it would swallow Mercury, Venus, Earth, and Mars, creating a catastrophic end for our planet. But why does this immensity lead to increased variability? The answer lies in the star's unstable nature. The outer layers of Betelgeuse are only loosely bound to its core due to its vast radius and the relatively low gravitational pull at its surface compared to smaller, more compact stars. This causes the star to pulsate irregularly, significantly changing its brightness as seen from Earth. Additionally, this pulsation allows large convective cells to form and move hot gas from deep inside the star to the surface. When this hot gas reaches the outer layers, it cools and sinks back toward the core, a stellar conveyor belt of sorts that not only stirs the star's atmosphere, but also contributes to the star's periodic dimming and brightening. Understanding Betelgeuse's structure gives astronomers critical clues about the life cycles of red supergiants and how such stars end their lives. Given Betelgeuse's advanced age and bloated size, it stands as a perfect laboratory for studying the final stages before a star goes supernova, offering insights not just into the star itself, but into the broader mechanisms governing stellar evolution. Scientific observations and tools. In our quest to unravel the mysteries of the cosmos, the role of advanced astronomical observatories cannot be overstated. Tools like the James Webb Space Telescope, the Hubble Space Telescope, and the Very Large Telescope stand as pillars of modern astronomy, providing us with the essential data needed to decode the behavior and structural changes of stars like Betelgeuse. The James Webb Space Telescope, with its unparalleled infrared sensitivity, allows astronomers to peer into the dusty veils surrounding stars, revealing hidden structures and temperatures that were once beyond our reach. This ability is crucial when studying a star like Betelgeuse, which often shrouds itself in a cloud of its own making. Meanwhile, the Hubble Space Telescope continues to offer invaluable support with its high-resolution capabilities. Its observations have helped track changes in Betelgeuse's size and surface activity over the years, providing a clearer picture of its pulsations and occasional ejections of material. The Very Large Telescope, situated in the arid deserts of Chile, complements these observations with its own unique capabilities. It employs a suite of instruments that can capture high-resolution images and spectra, allowing scientists to observe the star in different light spectrums. This multifaceted approach is essential, as the different wavelengths can tell us about various aspects of the star's surface and atmospheric conditions. The synergy of these observatories has turned Betelgeuse into one of the best-studied stars in our night sky. Each telescope contributes a piece to the puzzle, from mapping the star's vast surface to monitoring its light fluctuations and spectral signatures. This collaborative global effort not only enhances our understanding of Betelgeuse, but also sets the stage for understanding other similar stars across the galaxy. Through the lenses of these powerful observatories, we continue to witness the life story of one of the most intriguing stars visible to the naked eye. Astrophysicist Insights. As we delve deeper into the mysterious life cycle of Betelgeuse, it's crucial to consider the insights from renowned astrophysicist Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics. Dupree's research into this massive red supergiant reveals that Betelgeuse might currently be in a pivotal phase of its stellar evolution. According to her observations, the star could be nearing the end of its core carbon burning stage, a critical phase just before a star transitions into a supernova. The core carbon burning stage is one where a star like Betelgeuse converts its core carbon into heavier elements such as oxygen and magnesium. This process is a precursor to the collapse of the star's core, which could trigger the explosive and spectacular demise known as a supernova. Dupree suggests that this phase could conclude within the next few decades, positioning Betelgeuse on the brink of an epic cosmic event. What's particularly fascinating is how this assessment aligns with the unusual behavior we've observed from Betelgeuse in recent years. The increased frequency and intensity of its brightness fluctuations could be signaling that these internal transformative processes are more advanced than previously understood. This insight not only helps astronomers predict the star's future, but also offers a rare observational opportunity to study the pre-supernova activities in real time, a chance to witness firsthand the final chapters in the life of a star destined to end in a blaze of glory. Historical expectations. In the cosmic arena, our understanding of supernovae has been dramatically reshaped over recent decades. It was once firmly believed that only red supergiants were capable of culminating their stellar life cycles in the dramatic explosions known as supernovae. This view held sway in the astronomical community, grounding our predictions and theories in a framework that seemed unshakable, until 1987, that is. The year 1987 marked a pivotal shift in cosmic perceptions with the surprise supernova of a blue giant. This event sent shockwaves through the scientific community, challenging the long-held belief restricted to red supergiants. The blue giant, significantly hotter and more massive than its red counterparts, defied the expectations by undergoing a supernova, thereby expanding the scope of our understanding of stellar death. This paradigm shift not only widened our horizons regarding which stars could potentially go supernova, but also deepened our curiosity about the life cycles of stars across the spectrum. It underscored a fundamental lesson in astronomy. The universe often holds surprises that defy our expectations and assumptions. Each such event not only adds a new layer to our understanding, but also humbles us, reminding us of the vastness and the mystery of the cosmos that surrounds us. As we continue to observe and study stars like Betelgeuse, we do so with an awareness that what we know is only a fraction of what there is to learn, and what we expect is not always what occurs. Neutrino signals. In the cosmic ballet of the universe, neutrinos, those tiny, nearly massless particles, play a crucial yet often overlooked role. As Betelgeuse inches closer to its dramatic finale as a supernova, it's not just the visible light that will herald its cataclysmic end. Enter the neutrinos, ghost-like particles that rarely interact with matter. These particles could be the earliest messengers of Betelgeuse's impending supernova, providing a crucial heads-up before any visual confirmation is possible. Neutrinos are released in vast quantities during the core collapse of a supernova, a moment when the star's core implodes under its own gravitational pull, moments before the outer layers explode. The fascinating aspect of these particles is their ability to escape from the dense core of the star almost immediately after the collapse begins, traveling through space at nearly the speed of light. This means that neutrinos can reach Earth hours, perhaps even days, before the light from the supernova itself, which can get delayed as it bounces around within the exploding star. For astronomers and astrophysicists, detecting these neutrinos would not only signal that Betelgeuse has finally gone supernova, but also provide invaluable data about the processes occurring within the star's core in its last moments. Around the globe, detectors like the Super Kamiokande in Japan or the Ice Cube Observatory at the South Pole stand ready to catch these elusive particles. The detection of neutrinos from Betelgeuse would be a monumental event, marking only the second time in history that neutrinos from a supernova have been detected, the first being from supernova 1987A, which provided key insights into the life cycle of massive stars. As we monitor Betelgeuse's erratic behavior and shifting luminosity, the watch for neutrinos continues in earnest. These particles may soon serve as the silent heralds of one of the most significant astronomical events of our time, providing a precious few hours warning that a supernova spectacle is about to illuminate the heavens. This early warning could catalyze a flurry of scientific activity, with telescopes across the Earth poised to capture every moment of this stellar explosion in unprecedented detail. Thus, while Betelgeuse's light will fade, its legacy will shine brightly in the annals of astronomical discovery, enhanced by the ghostly glow of neutrinos. Potential impact of supernova. Imagine a day when you look up at the sky and see something brighter than Venus, bright enough to cast shadows on the ground at night. This isn't a scene from a science fiction movie. It's a very real possibility that could occur when Betelgeuse, one of the night sky's most notable stars, goes supernova. Betelgeuse, a massive red supergiant, is nearing the end of its life, and its eventual explosion as a supernova will be a sight to behold. The sheer magnitude of this event is hard to fathom. For context, Venus, often the brightest object in the night sky after the moon, can sometimes be visible during the day. Betelgeuse's supernova, however, will outshine Venus dramatically. This incredible luminosity means that for a period, possibly weeks, Betelgeuse will be visible both during the day and night, turning from a faint star seen in a dark night sky to a celestial beacon visible even under the sun's glare. What's even more fascinating is that despite its formidable appearance and intensity, this supernova poses no direct threat to Earth. The distance of Betelgeuse from our planet ensures that while the spectacle will be stunningly bright, it will not affect our environment or health. Instead, it offers a unique, harmless viewing opportunity that combines the thrill of a once-in-a-lifetime astronomical event with the safety of an ordinary celestial observation. For those worried about potential dangers, it's reassuring to know that while supernovae can emit harmful gamma rays and other energetic emissions, Betelgeuse's distance of about 650 light-years is enough to dilute these effects to negligible levels. The most impactful part of this event for us on Earth will be its breathtaking visibility and the way it lights up the sky, a phenomenon that will allow everyone around the globe to witness astronomical history in the making. In sum, Betelgeuse's dramatic changes offer an unprecedented glimpse into the late stages of red supergiants, refining our knowledge of stellar evolution and supernova mechanisms. By studying its unpredictable behavior, we uncover new insights into the universe's grand cycles, ultimately enriching our understanding of cosmic phenomena. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The universe is a vast and awe-inspiring place, and although Earth is an incredible planet, it is just a tiny speck in the grand scheme of things. With the advancement of technology, humans have been able to launch rockets and satellites into space, leading to an insatiable thirst for knowledge about the mysteries of the universe. While we have a decent understanding of how the universe works, much of our information is based on conjecture and speculation. That's why space probes like Voyager 1 and Voyager 2 are so crucial to our comprehension of the cosmos. These probes are beaming back real-time data, shedding light on the farthest reaches of our solar system and interstellar space, which we may not be able to visit for many years to come. But what happens when this data includes a terrifying warning that changes everything we thought we knew about the universe? Join us as we delve into what Voyager has discovered so far and the unsettling message it has sent us about the future. For nearly half a century, the Voyager missions have been at the forefront of space exploration, providing invaluable insight into the mysteries of our solar system. It's hard to believe that these missions were not intended to last this long, given the wealth of information they have yielded. The story of how the Voyager program came to be is a fascinating one. It all began with a fortuitous discovery by Michael Minovich, who realized that a spacecraft could use the gravity of a planet to slingshot further into space. This led to the launch of Voyager 1 and Voyager 2 in 1977, with the aim of studying Jupiter and Saturn. What followed was nothing short of a miracle. Both Voyagers are equipped with 3.7-meter radio dishes and 16 thrusters to adjust their orientation and direct their dishes towards Earth. Their engines use hydrazine fuel, and their electronic components are powered by plutonium-fueled thermoelectric generators. Both carry 11 scientific instruments, half of which were designed to study planets and have since been turned off. The grand tour of the 4 planets has now become a remarkable achievement in human exploration. Voyager 2 successfully completed the first-ever close observations of Uranus in 1986 and Neptune in 1989, while Voyager 1 overtook Voyager 2 a few months after launch, passing Jupiter in 1979 and Saturn in 1980, and has become the farthest distant artificial object from Earth. While Voyager 2 still has 5 functioning instruments, Voyager 1 only has 4, but they both remain crucial for gathering valuable data on the deep reaches of space. Today, the 2 spacecraft continue to journey beyond the Sun's influence and into interstellar space, sending back valuable data on the cosmic environment. Before delving into the messages received from Voyager 1, let's first look into some of the discoveries and things both the Voyagers encountered along the way. Imagine embarking on an epic journey to explore the uncharted depths of our solar system with 2 trusty spacecrafts as your companions. Your first mission? Take a closer look at the mighty Jupiter and Saturn systems. And boy, did those probes deliver! They transmitted a plethora of never-before-seen images and gathered extensive data, completely revolutionizing our understanding of these gas giants and the iconic ringed planet. But while Voyager 1 bid adieu to our solar system and ventured into interstellar space, Voyager 2 still had some exciting pit stops in store. In 1981, a corrective maneuver was made to set Voyager 2 on a course towards Uranus, and after exceeding its originally predicted lifespan twice, the spacecraft finally arrived at the remote ice giant in January 1986. But that was just the beginning. On its way to Uranus, Voyager 2 discovered 10 previously unknown moons, adding to the growing celestial family. But the ultimate destination was Neptune, where Voyager 2 captured more than 9,000 images and made an incredible discovery: 9 previously unknown moons. But that wasn't all. Triton, the largest of Neptune's moons, had some fascinating secrets to reveal. It turns out that Triton's diameter was not as previously thought, and the satellite had surprisingly few impact points on its surface. And its brown-white coloration? Geysers. These volcanic formations spew out liquid nitrogen that freezes into white nitrogen snow upon landing on the surface. With these incredible discoveries, the Voyager mission left an indelible mark on our understanding of our cosmic neighborhood. No other spacecraft has revisited Uranus and Neptune after Voyager 2's journey. However, scientists have still been able to observe and study incredible phenomena on these planets from afar. And now, get ready to be amazed as we reveal the secrets of these mysterious spectacles. Uranus. When it comes to ice giants in our solar system, the list is pretty short, with only 2 members, Uranus and Neptune. Despite the name, the majority of these planets' material is not actually frozen, but instead consists of hot, supercritical fluids made up of volatile chemical compounds like water, ammonia, and methane. It's a state of matter that combines the properties of liquids and gases. At an average solar distance of 1.8 billion miles, Uranus is the second outermost planet in our solar system, and its diameter is over 4 times that of Earth. It takes Uranus about 84 years to orbit the Sun, and during that time it does something strange. It appears to be lying on its side. The reason for this peculiar axis inclination is unknown, but scientists think it may have collided with a large protoplanet early on. This could also explain the 27 moons orbiting Uranus, which may have formed from the debris of the collision. And if that's not enough to intrigue you, a massive white spot was discovered on Uranus's upper atmosphere about 10 years ago thanks to the Hubble Space Telescope. It turned out to be a gigantic storm whipping around at speeds of up to 89 miles per hour, larger than the United States. But if you think that's wild, imagine the freezing temperatures of Uranus's methane and ammonia clouds, which can drop to a chilling minus 323 degrees Fahrenheit. And don't forget, just like Saturn, Uranus has its own ring system, although it's much sparser and less abundant. Neptune. In 1846, a bluish shimmering planet was added to the star charts, and we named it Neptune. This outermost planet of our solar system is nearly 3 billion miles away from the Sun, making it quite the loner. To put that in perspective, the distance between Earth and the Sun is only about 90 million miles. Despite its distance, Neptune is similar in size to its ice giant neighbor Uranus, with a diameter of 31,000 miles. However, in terms of mass, Neptune takes the cake with a whopping 17 Earth masses compared to Uranus's 14.5 Earth masses. Neptune takes a whopping 165 years to orbit around the Sun, but it spins quite quickly on its axis, taking only 16 hours to complete one rotation. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it captured some wild weather phenomena such as bright bands of clouds in the atmosphere and storms that reached top speeds of up to 1,305 miles per hour, the fastest winds observed on any celestial body. Experts believe that the lack of solar energy reaching Neptune allows these storms to whip up to such incredible speeds, but there is a chance they may disappear into thin air one day. During the Voyager 2 mission, scientists discovered the Great Dark Spot, a massive formation as large as Eurasia that was believed to be a hole in the planet's visible cloud cover. However, when scientists attempted to find the spot again a few years later, it was nowhere to be found. Some theories suggest that heat from Neptune's core caused turbulence in the atmosphere and tore the structure apart. Speaking of Neptune's core, despite the volatile nature of this planet, scientists believe it has a massive heart. The core is estimated to be 1 to 1.5 Earth masses and composed of metal and rock, with temperatures likely reaching nearly 13,000 degrees Fahrenheit and pressures estimated at several million bar. The magnetic fields of Uranus and Neptune have been a source of wonder for scientists for a long time. These invisible forces have a peculiar characteristic. They are tilted towards the rotation axis and deviate significantly from the planet's physical center. No one has yet unraveled the mystery behind these curious alignments. One thing that is certain is that Neptune's magnetic field is 27 times stronger than Earth's. On the other hand, Uranus's magnetic field is surprisingly weaker than our home planet's. Experts believe that the magnetic fields of these gas giants are generated by movements in comparatively small depth, possibly caused by ionized water. But that's not the only secret that lies within these planets. It is widely believed that Uranus and Neptune have massive cores surrounded by dense layers consisting of hydrocarbons, ammonia, and water. Scientists have been intrigued by the incredible processes that might be happening under the immense pressures at the center of these planets. One fascinating theory suggests that diamonds are raining inside Uranus and Neptune. This idea, which was once merely a thought experiment, was actually proven by a group of researchers a few years ago. The team used polystyrene, a plastic made up of hydrogen and carbon atoms, to recreate the extreme pressure conditions inside the ice giants. They sent 2 shock waves through the substance to see whether the hydrocarbon compounds would split under such pressure. The experiment generated a pressure of 1.05 million bar and raised the thermometer to a scorching 9,000 degrees Fahrenheit. The result was an astonishing shower of glittering diamonds, as nearly all the carbon atoms joined together to form tiny diamond structures. The diamonds that form in Uranus and Neptune would be much larger than those simulated in the laboratory. After they are created, these cosmic gems sink gradually towards the planet's core over a period of thousands of years. The thought of diamond rain on other planets is truly mind-boggling and adds to the intrigue and fascination of these mysterious gas giants. Over the past decade, the 2 probes have ventured into a vast and mysterious region known as the interstellar medium, the space between stars filled with sparse material. And they're still uncovering new discoveries. One of the most surprising findings is the strength and direction of the interstellar magnetic field, which has sparked lively debates among experts about the shape and activity of the Sun's magnetic domain, the heliosphere. Previously thought to be shaped like a comet, the heliosphere may actually be more spherical. And what happens to the heliosphere when sunspots appear and disappear? The spacecraft has provided some intriguing clues. When the solar wind, a flow of charged particles emanating from the Sun, comes to a halt, it marks the beginning of the interstellar medium. This ionized gas or plasma is like a rock in a river, pushing against the cooler, denser plasma flowing around it. The sun-carved cavity that forms is called the heliosphere, with its edge called the heliopause, similar to how the top of Earth's troposphere is called the tropopause. Don Gannett, a University of Iowa researcher who worked on the Voyager mission, says that when the spacecraft launched, they had no idea how far the heliopause was. Some speculated it could be as close as Jupiter, which is only 5 times further from the Sun than Earth. But as Voyager ventured further, estimates of the heliopause's distance increased, ruling out Jupiter, Saturn, Uranus, and Neptune. No one knew when or where the spacecraft would enter interstellar space. According to Don Gurnett, shortly after Voyager passed by Neptune, it detected signs of the heliopause in the distance. The spacecraft picked up strong radio waves between 2 and 3 kilohertz in July of 1992, which were later attributed to 6 significant flares on the Sun that occurred over a year prior. The researchers found that the plasma from the flares eventually made its way to the heliopause, where it caused electrons to oscillate and release radio waves. The frequency of these radio waves implied a density matching that expected for the interstellar medium, revealing that the local interstellar medium is far denser than the outer heliosphere. Despite appearing like a pure vacuum on Earth, it is actually quite tenuous. By calculating the speed of outbound solar material and the time it took to hit the boundary, the distance of the heliopause from the Sun was revealed to be between 116 and 177 astronomical units, providing a fascinating insight into our solar system's outer boundaries. When Gurnett claimed that Voyager had detected radio waves at the heliopause, he was met with skepticism from many scholars. Not only were these radio waves unprecedented, but Gurnett's interpretation of them also suggested that the heliopause was located at a significant distance from the Sun. To put this into perspective, the distance between the Sun and Neptune is just 30 astronomical units, while the heliopause seemed to be much farther away. Despite these doubts, Voyager 1 successfully crossed the heliopause at a distance of 121.6 astronomical units, consistent with Gurnett's prediction. However, due to the controversy surrounding the claim, NASA decided to delay the announcement of the accomplishment for over a year, although Voyager 1 did observe some indications that it had left the heliosphere, such as a decrease in high-energy particles from the Sun and an increase in cosmic rays from beyond the solar system. Many researchers were still not convinced. One issue was that Voyager's plasma instrument had stopped functioning, making it impossible to measure the sudden increase in particle density that occurs when leaving the heliosphere. Additionally, it was expected that the magnetic field would point in a different direction beyond the heliosphere, but this did not happen. Even today, scientists are still scratching their heads trying to explain why the magnetic field outside the heliosphere aligns with the magnetic field inside. It's a mystery that has yet to be solved. Voyager's incredible journey was partly aided by the Sun's outbursts. In 2012, massive solar storms stirred the plasma Voyager 1 traveled through, causing electrons to emit radio waves. These waves indicated that Voyager had entered a denser region of space. On November 5, 2018, Voyager 2 also crossed the heliopause without raising concerns. Its plasma instrument recorded a significant spike in particle density and higher temperatures, likely due to plasma compression when entering the heliosphere. Like Voyager 1, Voyager 2 observed the disappearance of solar wind and an increase in cosmic rays, with an unchanged magnetic field. Stamatios Tom Krimiges of Johns Hopkins University noted that both spacecraft crossed at similar distances despite different solar cycles in 2012 and 2018. The heliosphere, influenced by the waxing and waning of sunspots over an 11-year cycle, expands and contracts. Despite lower solar wind pressure in 2012 than in 2018, the similar distances suggest the heliopause is more resilient than previously thought. Despite the exact form of the heliosphere remaining a mystery, Voyager 1 and Voyager 2 continue to sail away from it. By the end of this year, Voyager 1 will be 155 astronomical units from the Sun, with signals taking over 22 hours to reach us. Voyager 2 will be 129 astronomical units away and is set to pass Pioneer 10 in late 2023 to become the second furthest spacecraft ever. These spacecraft are now further apart from each other than from Earth. In May last year, Voyager 1's Attitude Articulation and Control System, AACS, began sending confusing data. Despite this, the spacecraft remained in good shape, with a strong, steady signal indicating the antenna was still pointed at Earth. The AACS continued to experience issues, but the science systems functioned normally. NASA identified the problem as the AACS transmitting telemetry via a long-defunct onboard computer. Engineers instructed the AACS to use the correct computer, solving the issue. The next step is to determine what caused the system to switch in the first place. Although not a serious concern for Voyager 1's safety, identifying and correcting the fundamental cause is necessary to prevent future anomalies. In the vast expanse of interstellar space, Voyager 1 has been a true pioneer, journeying beyond the protective shield of our Sun's magnetic field for over a decade. Despite the hostile environment with high-energy particles and cosmic radiation bombarding the craft, Voyager 1 has continued to push forward, delivering valuable data and insights about the mysteries of deep space. According to Susan Dodd, the project manager for Voyager 1 and 2, Strange occurrences like the recent AACS malfunction are expected in this groundbreaking mission. After 45 years of exploration, the Voyagers remain a testament to human ingenuity and determination. Let's hear your thoughts about the Voyager mission in the comments section below.
The successor to the Hubble telescope, just about ready now to produce images of the universe like we have never seen before.
It's also one of the most complicated pieces of technology ever built. It contains over 3,000 sensors that continuously monitor the status of the hardware, so that technicians on the ground can keep an eye on what's happening.
The Hubble Space Telescope, humanity's eye into the vastness of space, has reportedly captured an image so mysterious, it stirred up more questions than answers. This isn't just any celestial body or distant galaxy we're talking about. This is something otherworldly. Today we're unraveling the tale of the City of God, a celestial phenomenon that has sparked debates, curiosity, and perhaps even a bit of fear. From a leaked photograph that took the world by storm to government cover-ups and the eerie sighting of celestial beings, this story has all the makings of a cosmic thriller. But what is the truth behind these bewildering claims? Are we on the verge of uncovering a divine presence in the universe, or is this a case of cosmic misinterpretation? And finally, if the City of God is real, what implications does it have for humanity's place in the universe?
Hubble has consistently taken us to places we've never been, visually, of course, and empowered us to answer questions that in a previous generation of telescopes we couldn't even pose.
So I think what excites me is that it shows us the wonder of the universe, places we can't get to right now.
NASA's achievements. Since the monumental day when man first set foot on the moon, NASA has not just rested on its laurels but has pushed the boundaries of what we believed was possible. With a brilliant team comprising the brightest minds in science, astronomers, engineers, and researchers, NASA has been the driving force behind the creation of spacecraft that seem to lead straight out of science fiction. These marvels of engineering have traversed the galaxy, sending back information that has unveiled the cosmos layer by layer. Each mission, from the Mars rovers to the Voyager probes, has been a thread in the rich tapestry of space exploration, revealing the mysteries of our solar system and beyond. But it's not just about the destinations, it's also about the incredible journeys. The development and deployment of the Hubble Space Telescope stand as a testament to NASA's ingenuity and quest for knowledge. Hubble, orbiting Earth, has acted as humanity's window to the universe, capturing images that have not only advanced our understanding of the cosmos, but have also inspired millions around the globe with stunning visuals of distant galaxies, nebulas, and stars. Through decades of dedication, NASA's efforts have peeled back the layers of the cosmos, revealing the beauty and complexity of the universe in unprecedented detail. These achievements are not just milestones in the annals of space exploration, but are beacons of human curiosity and our unyielding desire to explore the unknown. Terrifying image discovery. In one of the most electrifying updates from the cosmos, the Hubble Space Telescope has sent back an image that sent shockwaves through the scientific community and beyond. This isn't your ordinary snapshot of distant stars or swirling galaxies. Note, this image is different. It's been described as terrifying, not because of its eerie aesthetics, but because of the profound questions it raises about our very existence in the universe. Imagine the Hubble orbiting silently in the cold vacuum of space, its lens trained on the infinite cosmos. It captures countless wonders on a routine basis, from the birth of stars to the death of galaxies, each image a testament to the natural beauty of the universe. But among these routine captures, there emerges an image so unexpected, so out of place, it takes everyone by surprise. The image reveals what appears to be a structure, a composition so precise and unfamiliar that it defies all conventional understanding of cosmic formations. The immediate reaction is one of disbelief and shock. Scientists, used to deciphering the mysteries of the universe, find themselves at a loss, questioning not only the nature of this discovery, but also its implications for humanity's understanding of the cosmos. This is no mere celestial anomaly. Its presence suggests that there could be aspects of the universe that are entirely unknown to us, hidden realms or civilizations that exist beyond our current scientific comprehension. The potential impact of this discovery on our understanding of existence is monumental. It challenges the very foundations upon which our cosmic knowledge is built, inviting us to reconsider what we thought we knew about the universe. Alleged discovery of heaven. The core of our story revolves around an alleged photograph leaked from none other than NASA itself. This isn't just any photo. We're talking about a snapshot that reportedly reveals a sprawling, large white city floating in the void of space. Captured on December 26, 1994, this image quickly transcended from a confidential discovery to a global phenomenon, sparking shock and awe not just among the public, but within the scientific community as well. What makes the story even more intriguing is the context and the timing of the discovery. It came from the Hubble Space Telescope, humanity's most advanced eye in the sky, which has been peering into the deepest recesses of the universe since its launch in 1990. The photograph in question surfaced at a time when the internet was just beginning to weave its web around the globe, a period ripe for rapid information exchange and, of course, speculation. Imagine the scene in NASA's offices when scientists first laid eyes on this baffling image. It was unlike anything they had seen before, a celestial anomaly that defied immediate explanation. The initial shock among the team was palpable. Here was a highly sophisticated space telescope designed to explore the cosmos and answer humanity's most profound questions, presenting them with an image that seemed to raise more questions than answers. The photographs leaked to the public turned the scientific curiosity into a wildfire of speculation. The idea of a city floating in space challenges our understanding of the universe, provoking discussions about the nature of celestial bodies, the possibility of other civilizations, or even the concept of a heavenly abode. As this image made its rounds across the nascent internet, it became a subject of fascination, debate, and wonder. People from all walks of life weighed in with their interpretations, theories, and understandably, their skepticism. The scientific community was left to grapple with the implications of such a discovery, while the public imagination ran wild with the possibilities of what this city could represent. Public and governmental reaction. In today's digital age, the line between the extraordinary and the unbelievable blurs faster than a shooting star streaking across the night sky. But what happens when a discovery so monumental comes to light? It threatens to unravel the fabric of our reality. This is the story of an image captured by the Hubble Space Telescope that did just that. A photograph depicting what many have come to call the City of God, a celestial marvel that has set the internet ablaze with speculation, wonder, and a fair share of skepticism. Within moments of its alleged leak, the image coursed through the veins of the internet, igniting discussions in every corner of the globe. Chat rooms, forums, and social media platforms became the stages for heated debates and wild theorizing. The picture, showing a vast, white city amidst the stars, was nothing short of a revelation. A glimpse into the divine, or perhaps a cosmic anomaly yet to be understood. But with great revelation comes great responsibility and perhaps great panic. The US government, sensing the potential for public unrest in the wake of such a bewildering discovery, moved swiftly, albeit not swiftly enough. Before the images could be tucked away into the classified archives, they spread far and wide, a testament to the age-old adage, once on the internet, always on the internet. The attempt to classify the images was seen by many as a knee-jerk reaction to control the narrative, to keep the public in the dark about a discovery that could redefine human existence itself. This action, rather than quelling curiosity, only fueled it further, leading many to question what else might be hidden within the vaults of governmental secrecy. As the images continued to circulate, the line between fact and fiction blurred. Skeptics called it a hoax, a clever manipulation of light and shadow. Believers saw it as proof of the afterlife, a celestial city awaiting us all. The truth, as it often does, lay somewhere in between, shrouded in the mystery of the cosmos and the limitations of human understanding. Further analysis and observations. Now let's dive into further analysis and observations of the anomaly initially captured by the Hubble Space Telescope. After the initial shockwave caused by the leaked images of a supposed celestial city, NASA's finest minds convened in an urgent effort to clarify the mysterious findings. With the world buzzing with theories and speculation, the decision was made to task the Hubble telescope with a mission of utmost importance. This wasn't merely a second glance. It was a full-scale, high-resolution investigation aimed at piercing the veils of the cosmos to uncover the truth behind the anomaly known as the City of God. Equipped with cutting-edge technology, the Hubble was meticulously programmed to capture the anomaly in the highest possible resolution. Scientists were not just looking for answers, they were seeking undeniable proof of what the structure truly was. The stakes were as high as the anticipation that filled the laboratory air. As the Hubble telescope focused its lenses on that specific section of the starry sky, hearts raced. The gathered scientists and astronomers knew they were on the cusp of potentially rewriting history. The subsequent capture of the photograph was a moment of truth. With bated breath, the image was projected onto a very big screen, instantly seizing the undivided attention of everyone present. What was revealed was nothing short of astonishing. The previously foggy and ambiguous spot was now clear, unveiling a structure that was at once luminous and architecturally complex. It was as if a light was shining from within the structure itself, casting an otherworldly glow across the cosmos. This presumed city, with its resemblance to speculative fiction and futuristic depictions, stretched into the vast expanse of space, igniting a myriad of questions and theories. Skeptical views and scientific inquiry. In a twist that's as intriguing as the discovery itself, the narrative shifts gears, ushering us into the realm of skepticism and scientific inquiry. This turn of events throws a shadow of doubt over the celestial spectacle, painting it with strokes of uncertainty and speculative fiction. As we delve deeper, it becomes clear that not everyone is ready to take the leap from observable science to the acceptance of a city of God floating in the cosmos. The skepticism isn't without reason. The scientific community, known for its rigorous standards of proof and evidence, finds itself at a crossroads. The image, while mesmerizing, raises as many questions as it purportedly answers. Could this be a case of cosmic pareidolia, where human perception sees familiar patterns in random or vague images? Or perhaps a misinterpretation of astronomical data, transformed into a narrative more suited to science fiction than to empirical science? The narrative underscores the potential for overinterpretation, a common pitfall in the quest to make sense of the unknown. With excitement reaching feverish heights, the distinction between hard evidence and the allure of speculative fiction becomes blurred. This skepticism serves as a reminder of the importance of grounding extraordinary claims in solid scientific methodology and evidence. As the story unfolds, the skepticism doesn't just challenge the veracity of the City of God, but also ignites a broader discussion about the nature of discovery and the human inclination to find meaning in the mysteries of the universe. It poses an essential question to us all: where do we draw the line between the pursuit of knowledge and the seductive pull of storytelling that ventures into the realms of speculative fiction? The city's movement and cosmic role. As scientists scrutinized the images captured by the Hubble Space Telescope, they uncovered a movement that aligns with the grand cosmic bolide. The city doesn't merely float in space. It follows a path that adheres to the fundamental laws of the universe we thought we understood. But here's where it gets even more fascinating. The city is described as acting almost like a cosmic lighthouse, a point from which galaxies seem to drift away. This movement isn't random chaos. It's orderly, following the principles laid out in the Big Bang Theory, suggesting that this city is not just a part of the universe, but a central figure in its expansive dance. This revelation sends ripples through our current cosmological models, challenging the way we perceive the structure and dynamics of the cosmos. Imagine a model of the universe where Earth isn't at the center, nor is the Sun, but perhaps this mysterious city of light. Scientists have even employed computer models to illustrate how galaxies drift away from this enigmatic point, inviting us to reconsider our place in the universe's vast tapestry. What does this mean for our understanding of cosmic movements and the forces that govern them? Are we looking at a gravitational anomaly, a celestial mirage, or a beacon from which the universe itself expands? Allegations of NASA hiding the discovery. As the story unfolds, we find that following the initial leak of this extraordinary image, the reaction was swift and shrouded in secrecy. The US government allegedly stepped in with a heavy hand, classifying the images to stifle the swell of public unrest. This wasn't merely a routine operation. It was an act driven by the fear of the unknown, a testament to the potentially destabilizing impact of the discovery on societal norms and beliefs. But the plot thickens. Despite efforts to keep the images under wraps, a photographer at Ellington Airfield, armed with nothing more than a camera and a keen eye, managed to capture snapshots of this supposed celestial marvel. These images, adorned with structures that seemed to defy human comprehension, found their way onto the internet, igniting a firestorm of speculation and debate. In the heart of this intrigue lies a critical question. Why would NASA, an institution dedicated to the pursuit of knowledge and the dissemination of cosmic discoveries, choose the path of secrecy? The implications of such a decision are profound, suggesting a discovery so impactful, so revolutionary, that it compelled a response aimed at controlling the narrative to keep the public in the dark. Decoding the image for further evidence. As we decode this image, we're confronted with formations that seem impossibly structured, bearing an uncanny resemblance to the architectural feats of an advanced civilization. Towers that stretch towards the stars, domes that shimmer with an ethereal glow, and perhaps most intriguingly, figures that appear distinctly lifelike. These elements have thrown the scientific community into a whirlwind of speculation and debate. But what makes these formations stand out is not just their apparent artificiality. It's their placement within the vastness of space, a location where no human architect could have possibly erected them. The detailed analysis brings forward more questions than answers. How could such structures exist in the void of space? Are these truly the makings of an advanced civilization? Or is there a more mundane explanation, one rooted in the bizarre and often deceptive nature of cosmic phenomena? As we explore this celestial mystery, we must consider the possibilities. Could optical illusions, a common trickster in astronomy, be at play here? Or have we stumbled upon a discovery that challenges our very understanding of the universe? The implications of this image are as vast as space itself, inviting us to ponder not just on the origins of these anomalous structures, but on the very nature of existence beyond our earthly confines. Angels and celestial phenomena. Alongside the images of the celestial city, there have been reports of figures resembling angels in the vicinity, adding a layer of mystique to an already extraordinary discovery. This isn't a scene from a science fiction novel. These reports come from meticulous observations, with the figures described as having brilliant orange hues, massive wingspans akin to that of airplanes, and an appearance of joy as if they were reveling in the act of being photographed by humanity's most advanced telescope. But this narrative isn't without precedent. In an echo from the past, Soviet cosmonauts during the Soyuz mission reported encountering a band of bright, smiling angels in space, suggesting that what the Hubble has captured might not be an isolated phenomenon. These historical encounters present us with a tantalizing question. Have we, across the years and through the lens of different cultures and technologies, been witnessing the same celestial phenomena? The implications of these sightings are profound, bridging the gap between the known and the unknown, the scientific and the mystical. As we delve deeper into the cosmos, these encounters remind us of the vastness of the universe and the possibility of realities beyond our current comprehension. Public and cultural reaction to the discovery. The City of God image, allegedly captured by the Hubble Space Telescope, became a mirror reflecting humanity's deepest yearnings and beliefs. Across the globe, people from all walks of life found themselves grappling with the implications of this celestial phenomenon. Was this the architectural manifestation of the divine, a celestial abode among the stars? The very thought seemed to bridge the gap between science and spirituality, offering a tantalizing glimpse into the eternal. The reaction was as diverse as it was intense. For some, the discovery affirmed long-held beliefs in a celestial beyond, while for others, it sparked curiosity and a revaluation of their understanding of the universe. Social media platforms and internet forums buzzed with theories and interpretations, showcasing humanity's unquenchable thirst for understanding the mysteries of existence. In this period of collective reflection and wonder, the City of God became more than just a potential cosmic discovery. It evolved into a cultural phenomenon. It prompted discussions not only about the scientific implications, but also about the philosophical and spiritual questions it raises. How do we reconcile our place in the universe with such revelations? What does it mean for our understanding of life, existence, and the afterlife? Comparative analysis with past claims. This isn't the first time humanity has been captivated by the idea of celestial cities or heavenly bodies lurking in the vastness of space. Remember the buzz around the gates of heaven? Back in 2016, an image allegedly showing the entrance to the celestial realm made rounds online, sparking awe and debate. However, it turned out to be a work of art, a creative interpretation of cosmic phenomena, not an actual celestial gateway. This pattern of sensationalism isn't limited to just heavenly cities or gates. Over the decades, numerous claims have surfaced, suggesting that NASA has stumbled upon evidence of the divine or the extraterrestrial. These narratives often gain traction quickly, fueled by humanity's innate curiosity and fascination with the unknown. Yet, time and again, upon closer scrutiny, these claims are grounded more in imagination than in empirical evidence. The allure of finding divine or otherworldly signs in the cosmos is undeniably strong. It speaks to our deepest questions about existence, spirituality, and our place in the universe. The City of God narrative, with its descriptions of towering structures, angelic beings, and a celestial city that moves with the galaxies, taps into this allure. It presents a cosmic mystery wrapped in the veneer of divine revelation. But as we've seen with past claims, the excitement of such discoveries often outpaces the reality of the evidence. The Hubble Space Telescope, a marvel of modern science, has indeed revolutionized our understanding of the cosmos, revealing the universe's beauty and complexity in unprecedented detail. Yet its findings are subject to the same rigorous scrutiny and scientific standards as any other scientific endeavor. Debunking and rational skepticism. Historical precedents remind us to tread carefully when interpreting celestial photographs. Recall, for instance, the 2016 incident involving an image purported to showcase the gates of heaven. Initially captivating the public's imagination, this image was later revealed to be a work of art, not an authentic celestial snapshot. The artist, utilizing a technique known as pixel sorting, transformed an actual Hubble image of the Swan Nebula into the so-called Gates of Heaven, inadvertently igniting a flurry of speculative claims. This isn't an isolated case. The Weekly World News, known more for sensational stories than scientific reporting, published the original story about heaven being photographed by the Hubble telescope. While engaging, the publication's track record invites skepticism regarding the authenticity of such claims. Further inquiry into the story's foundation reveals a pattern of misinterpretation and occasionally outright fabrication of celestial phenomena. Moreover, when examining the supposed images of the City of God, the presence of diffraction spikes becomes a point of contention. These spikes, characteristic of images captured by mirror-based telescopes, are often misinterpreted by the untrained eye. However, their presence, shape, and orientation can reveal the source of an image, shedding light on its authenticity. In the case of the City of God, discrepancies in these details hint at the possibility of manipulation or misrepresentation. In the cosmic quest for understanding, the line between discovery and deception can be thin. As we've seen with the City of God, what begins as a captivating visual can lead us down a path of speculative fiction rather than empirical truth. The history of space exploration is dotted with instances of misinterpretation and the allure of finding the divine in the cosmos. Yet, each of these moments serves as a reminder of the importance of critical thinking and the need for rigorous scientific scrutiny. What do you think about this? We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now.
The little spacecraft that could, Voyager 2, is heading for its closest encounter yet with the planet Neptune. It's now billions of miles from...
While Jupiter boasts its mesmerizing storms, Mars captivates with its potential for life, and Saturn dazzles with its stunning rings. Courtesy of the Cassini spacecraft's 13-year grand tour, Neptune seems to quietly orbit in the distant chill of space. It's the 8th planet from our Sun, remote and enigmatic, often overlooked in the bustling solar system family. So why does Neptune receive less attention compared to its planetary siblings? Let's dive deep into the blue to uncover the mysteries and majesty of this distant ice giant. Join us as we explore what makes Neptune unique and why it deserves a closer look. Named after the Roman god of the sea, Neptune is often referred to as an ice giant due to its composition, which consists primarily of hydrogen, helium, and traces of methane. With a diameter about 4 times that of Earth, Neptune boasts a striking blue hue attributed to the presence of methane in its atmosphere, which absorbs red light and reflects blue. Discovered in 1846, Neptune's exploration has been limited compared to its closer planetary counterparts. However, the historic flyby of NASA's Voyager 2 spacecraft in 1989 provided invaluable insights into this distant planet, unveiling its dynamic weather patterns, unique moons, and fascinating rings. Among its moons, Triton stands out for its retrograde orbit, moving opposite to Neptune's rotation, suggesting a complex history of capture and gravitational interactions. Neptune's atmosphere is characterized by powerful storms, including the Great Dark Spot, reminiscent of Jupiter's Great Red Spot, showcasing the planet's turbulent and dynamic nature. Despite its remote location and challenges associated with exploration, Neptune remains a target of scientific curiosity, offering valuable opportunities to expand our understanding of planetary systems and the evolution of our solar system. While Mercury often steals the spotlight in astrology due to its perceived retrograde motions, which enthusiasts often blame for disruptions and challenges, the truth is far less mystical. It's merely an optical illusion resulting from the relative positions of Earth and Mercury in their orbits. However, despite Mercury's frequent appearances in astrological discussions, Neptune remains largely overlooked. Its astrological influence, while less discussed, is equally intriguing, governing realms of dreams, intuition, and mysteries. This discrepancy between the attention given to Mercury and the relative neglect of Neptune in astrology reflects the elusive and distant nature of the latter within the solar system. It underscores the vast difference between the roles planets play in astrology and their exploration in the realms of physical science. Focus on ice giants. Neptune and Uranus, often overshadowed by their larger gas giant cousins, hold a special place in the pantheon of our solar system as ice giants. This classification stems not from their being literal ice, but from their intriguing construction, largely from substances like water, ammonia, and methane, which in the cold depths of space form icy compounds. Both planets share a similar size, being significantly larger than Earth yet smaller than Jupiter and Saturn, which places them in a unique category of their own. Their atmospheres are thick with hydrogen and helium, but it's the methane that really sets them apart, absorbing red light and giving these distant worlds their characteristic blue hues. What's particularly fascinating about Neptune and Uranus is their internal structure, which, under extreme pressures, might form diamonds from compressed carbon atoms, a phenomenon that remains a tantalizing possibility not observable on the gas giants. This unusual atmospheric and internal chemistry makes Neptune and Uranus key subjects in planetary science, offering insights into not only planetary formation and evolution, but also into conditions that are utterly alien compared to those found on terrestrial planets. The mystery of Neptune's color. In a fascinating twist of scientific inquiry, a study initially focused on the broader atmospheric characteristics of Neptune ended up shedding light on one of the planet's most captivating mysteries, its striking blue color. Led by Patrick Irwin, a planetary physicist at Oxford University, the team set out to explore the atmospheres of both Neptune and Uranus. Their research was not originally intended to delve into why Neptune exhibits such a vivid azure hue. However, the findings inadvertently provided valuable insights. The team discovered that Neptune's color is primarily due to the absorption of red light by methane in its atmosphere, which leaves behind the richer blues and greens that we see. Further analysis revealed an interesting distinction between Neptune and its celestial twin, Uranus. It turns out that Neptune has a thinner layer of methane haze compared to Uranus. This thinner haze allows for a deeper, more intense blue to emerge, setting Neptune apart in the visual spectrum of the solar system. This discovery highlights how scientific journeys can sometimes yield unexpected yet enlightening results, deepening our understanding of the planets beyond our Earth. History of exploring Neptune. Neptune's exploration story, though not as extensively documented as Mars or Jupiter's, is undeniably captivating. A pivotal moment in our comprehension of Neptune unfolded with NASA's Voyager 2 spacecraft embarking on a historic flyby in 1989. This mission stands as the sole instance where we've had the opportunity to closely observe Neptune. As Voyager 2 soared past, it bestowed upon us breathtaking images that revolutionized our perception of this distant world. It unveiled a vividly blue planet, adorned with subtle rings and intriguing moons. Among these, Triton stands out, its orbit around Neptune defying convention by moving opposite to the planet's rotation, hinting at a potentially unique origin story. Voyager 2's flyby yielded invaluable insights into Neptune's atmosphere, unveiling its dynamic weather patterns, including the remarkable discovery of the Great Dark Spot, an Earth-sized storm showcasing Neptune's tumultuous nature. This mission profoundly enriched our comprehension of the outer planets and endures as a pivotal moment in planetary science. Through Voyager 2's journey, we ventured farther into the depths of our solar system, unraveling the mysteries of Neptune and expanding our understanding of the vast celestial landscape beyond. Neptune's storms and atmospheric phenomena. Neptune's atmosphere is alive with dramatic weather phenomena, most notably its storms, which can be as captivating as they are mysterious. The most famous of these is the Great Dark Spot, discovered by NASA's Voyager 2 during its 1989 flyby. This massive storm, roughly the size of Earth, showcased the fastest winds ever recorded in our solar system, reaching speeds of up to 200 kilometers per hour. However, unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's storms show much shorter lifespans. The Great Dark Spot had completely vanished by the time the Hubble Space Telescope observed Neptune in 1994, illustrating just how quickly these colossal weather systems can change. These rapid transformations hint at a highly dynamic atmosphere where storms develop and dissipate much faster than on Jupiter. The fleeting nature of these storms poses a significant challenge for scientists trying to study them. By the time a telescope like Hubble makes a return observation, the atmospheric landscape may have completely altered. This transient behavior makes Neptune's atmosphere one of the most volatile and least understood among the solar system's giants, inviting more in-depth exploration to unravel its meteorological mysteries. Role of Triton and other moons. As we delve deeper into Neptune's celestial family, we cannot overlook Triton, Neptune's largest moon. This intriguing moon captures the imagination with its peculiar retrograde orbit, meaning it moves in the opposite direction to Neptune's rotation. This unusual path suggests a dramatic origin story for Triton, likely captured by Neptune's gravity rather than forming alongside it. Such a capture is not just a spectacle of celestial dynamics, but sheds light on the migration histories of other objects in our solar system. Triton isn't just notable for its orbit. It's slightly larger than our own moon and showcases a surface rich with geological features, pointing to a potentially vibrant past. This includes the likelihood of a subsurface ocean, making Triton a key player in Neptune's system and a target of high scientific interest. Surrounding Neptune, several other moons orbit, most of them smaller and irregularly shaped compared to Triton. These moons, along with the planet's delicate ring system, form a complex gravitational dance that influences the system's stability and evolution. Understanding these interactions helps astronomers piece together the dynamic processes governing the outer solar system, providing clues about the formation and evolution of planetary systems as a whole. Current and future observations. The James Webb Space Telescope, JWST, our most advanced space observatory, has recently turned its powerful gaze towards Neptune, offering us some of the clearest and most detailed images of this distant planet in over 3 decades. With JWST's sophisticated instruments, we're peering into the icy depths of Neptune's atmosphere and gaining unprecedented views of its intricate ring system and numerous moons. The telescope's ability to capture high-resolution images in infrared light has illuminated features that were previously too faint to discern. This includes several of Neptune's lesser-known moons and the fine particles that compose its rings, revealing new details about their composition and dynamics. These observations are crucial as they not only enhance our understanding of Neptune's physical properties, but also help astronomers piece together the planet's evolutionary history and its current meteorological phenomena. The data gathered by JWST is expected to keep scientists busy for years, unlocking secrets of the furthest reaches of our solar system. This rich influx of data from JWST marks a significant milestone in our quest to understand Neptune's complex climate system, its unique atmospheric chemistry, and its dynamic environment. Challenges in exploring Neptune. Exploring Neptune presents unique challenges, primarily due to its immense distance from the Sun, approximately 4.5 billion kilometers away. This vast expanse not only increases travel time and costs, but also poses significant technical hurdles for communication and power supply. Spacecraft venturing to Neptune must rely on radioisotope thermoelectric generators for power, as solar energy is too weak at such distances. These generators convert the heat from radioactive decay into electricity, providing a reliable source of power for the spacecraft's instruments and systems. Moreover, Neptune's remote location means that any mission there faces prolonged communication delays, complicating real-time command or data retrieval. The round-trip communication time between Earth and Neptune can range from hours to days, depending on the positions of the planets in their respective orbits. This isolation requires spacecraft systems to operate autonomously for extended periods, making them highly reliant on pre-programmed commands and onboard decision-making algorithms. Despite these difficulties, Neptune's exploration is crucial for understanding the outer solar system and uncovering the mysteries of ice giants. By studying Neptune's atmosphere, magnetic field, and moons, scientists can gain insights into planetary formation and evolution beyond the realm of terrestrial planets. However, these logistical complexities have led to Neptune being visited less frequently than its closer, and perhaps more immediately intriguing planetary neighbors like Mars and Jupiter. Nonetheless, the scientific community continues to advocate for future missions to Neptune, recognizing the invaluable knowledge they could yield about our solar system's distant frontier. Future missions and scientific goals. In the realm of planetary exploration, the scientific community has set its sights on some ambitious missions for the future, with Neptune featuring prominently in their plans. Currently, there's a lively debate about the next big target for a dedicated orbital mission in our outer solar system. While Neptune remains a candidate for exploration, the focus has somewhat shifted towards Uranus. Scientists recommend prioritizing a mission to Uranus within the next decade, citing its accessibility and the potential to yield significant scientific data swiftly. Despite this prioritization, the fascination with Neptune continues to grow, compelling the scientific community to consider a detailed exploration of this distant planet. A proposed mission plan suggests launching a spacecraft to Neptune around 2033, with an expected arrival in 2049. This timeline could be extended if Uranus is indeed chosen first, possibly pushing Neptune's close examination to the mid-2050s. The goals of these future missions are robust and revolve around a deeper understanding of the ice giants. Researchers aim to study Neptune's dynamic atmosphere, its intriguing storm systems, and its magnetic environment. Moreover, there's a strong interest in Neptune's moons, particularly Triton, with its retrograde orbit and geologically active surface, which could provide crucial insights into the solar system's history and evolution. These missions are expected to deliver groundbreaking data, helping to unravel some of the enduring mysteries of our solar system's most distant planets. Neptune occupies a unique position as the most distant major planet in our solar system, often overlooked in the race to explore closer and more accessible celestial bodies. Its status as an underappreciated giant belies the intriguing mysteries and scientific potential it holds. As the final frontier in planetary exploration, Neptune offers a gateway to understanding not only the dynamics of ice giants, but also the broader mechanisms at play in the outer reaches of our solar system. Future missions to Neptune could unravel these enigmas, enhancing our knowledge of planetary formation, evolution, and the peculiarities that govern such distant worlds. As we consider sending probes to its orbit, the lessons learned from Neptune will likely illuminate countless unknowns about our cosmic neighborhood, underlining the importance of reaching out to this distant blue planet. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.